sharing my screen.
Okay. Okay. Okay, so it's 2. So we are starting today's session. Welcome everybody once again. So it is my privilege to introduce Dr. Santanu Das, an entrepreneur and technology leader committed to building solutions that address meaningful real-world challenges. Dr. Das began his journey in data science at NASA, where he worked on mining complex datasets to support aviation safety and space missions. He later held leadership roles at leading technology companies like Verizon, Palo Alto Networks, Cisco, driving the development and deployment of scalable AI and machine learning products. Guided by a vision for positive impact, Dr. Das went on to co-found mission-driven startups. He His work spans diverse field from accelerating scientific discovery to in biotechnology to advancing sustainable solution in green mobility. He brings together a strong analytical mindset and strategic leadership to transform innovative ideas into tangible, sustainable outcomes that serve the greater good. We are truly honored to have him with us today. Please join me in welcoming Dr. Shantanu Das to deliver his address. So topic is from domain modeling to applied insight, a graph-based approach. Right now, he is CEO, Cinter AI Inc. USA and CTO, GenRAIT Inc. USA. Welcome to you, Dr. Das. Means over to you, Dr. Das.
Hi, everyone. I'll just switch on my camera for 1 or 2 minutes just to make sure you are not talking to a bot. Uh, so, uh, so my name is Santanu Das, and so first, what I'm going to do is just share a little bit of story because I'm located in San Francisco, Bay Area. So when I have been talking to Dr. Dipankar Dutta about this talk, what I'm privileged of in order to get an opportunity to present what I have been doing. Now, with little context, I told Dipankar that I am not a early riser. That's what I told him. Now, because of the lack of context, he gave me a talk, which is like 1:30 in the morning. So my present current time. So Dipankar, your job will be to make sure I don't fall asleep in the meantime. Okay. So that's your job. Um, Now, said that, I think for the bandwidth issue, we will not actually keep the camera on for long because I think it may slow down the internet. But we will jump into the content, okay? And throughout this conversation,
You can keep it on, no problem.
okay, throughout this conversation,
Yes,
I
yes,
think if
yes, yes, no problem.
Sure. Yes. So throughout this conversation, make it more friendly. If you have questions or if you want me to explain on certain aspect of it, please do so. Please stop me or raise your hand or maybe delegate your question to Dr. Datta, and then he can actually summarize the entire thing at the end, right? Basically, what questions you have, and we can have some conversation. High level, the way I have been looking into it is uh, today's content. Kind of like we'll kind of do a slideshow and some sort of like demonstration, plug and play kind of stuff in the first 1 hour. the last 30 minutes, I would definitely would love to talk to you folks. If you have specific questions, or maybe something related with the presentation or something related to what you have been working on, uh, we'll be happy to do the conversation. The whole objective is that we learn something today and kind of get into the application side. Okay. So with that, I will actually jump into the conversation directly. Thank you so much, everyone, once again for the opportunity. And I think it's a pleasure for me to be here, uh, in front of all of you folks. And today, there are two aspects of it. Me being an individual in this field, particularly for the machine learning AI, I have been working on this for the last 25 years. Did my PhD from Arizona State, um, and then joined NASA, working for the computer science team. A lot of fun projects there. Uh, Also worked for Verizon, big data area. Those are like petabytes of data which are coming from consumers. Palo Alto Network is more on the cybersecurity side, because as we know that data assets are vulnerable. So how to protect them, how to bring in security, and all this aspect. Okay. Now, more recently, by that I mean in the last 5 years, 4 to 5 years, I got interested in entrepreneurship. I have been working on multiple initiatives, and that's something I love to do all the time. One of them is GenRAIT. GenRAIT Inc. is actually more on building genomics platform. Uh, Most likely, all of you know about this. Genome data is actually invaluable. Basically, it's kind of the next level of the blood test, where you can proactively find what kind of issues are going on with your health, my health, or any individual's health. And you can figure out long-term solutions, where if you can, either through medications or through practices or through various other techniques, if you can alter, change, or maybe kind of like in extreme cases, edit your genome sequences, then you can get rid of this disease. You can get rid of certain practices or certain behavioral aspect of it, right? So that was the purpose of generating. Now, genome data is huge. It's a big data issue, and to give you a little bit of context here, uh, depending on the resolution of the data, it can get from 30-40 gigabytes up to half a terabyte of data each genome file, right? So it's kind of complex in terms of big data. And then the second level of complexity there was more on the side of tertiary analysis. For example, cancer genomics, ADHD, obesity, all these kind of stuff are being solved through genomic analysis, and that was the goal of this platform. And then the second initiative, which I started in India particularly, that's more on the green mobility side. However, the whole objective was market connectivity. So can we actually think about it as simple as, uh, can we make transportation more affordable for the medium to low income groups? That's one objective of eVibe. And then something like, how do we increase the income for farmers who are struggling with market connectivity issues? Middleman gets most of the profit. How do we handle that? So these are some of the things I still do handle. Some initiatives going on in southern part of India, Tamil Nadu, and so forth. Headquarters is in Tamil Nadu, by the way. and then some of the initiatives going on in Northeast, particularly Meghalaya. Those are, West Bengal. I have some presence there. I have presence in Ludhiana and all this stuff. So, but the major initiatives are going on in these two places. Now, apart from that, we talked about another initiative called Sinter AI. Sinter AI is fairly new, by the way. Sinter AI, I started this initiative a few months back, and for a reason, because in a few minutes we will like kind of see what Sinter AI does and what its goal is. But in short, if you think about it, is in Sinter AI, the whole objective is that we transform complex knowledge. Think about industry-specific rules, industry-specific data sets. How do we actually take those rules? How do we take that data and kind of transform it into complex knowledge, process this complex knowledge, and eventually the goal is to convert it or turn it into actionable intelligence. That's what Sinter AI's high-level goal is, and this essentially means that we'll be using structured representation of this knowledge, this information, right? Like ontologies, like building knowledge graphs, and eventually these graphs are going to power enterprise level process, enterprise level applications. That's the goal. Okay, and that brings me to today's presentation and its goal. So today, what we are going to discuss, and I'm going to show you how uh, graph-based approaches can bridge between domain expertise to practical insights. That's actually, if you think about it in one line, that's what we are going to talk about today. Okay. Now, uh, think about what are we going to cover, what we are not going to cover from the graph models, right? We are not going to talk about graph data structure. I'm pretty sure most of you are familiar with it or can get familiar with it easily. We are not going to cover that. We are also not going to cover about specifications, about like what tools should I use for graph, like Neo4j or something. You can choose your favorite, and some of the top tools are always at par with with the industry standards. So we are not going to talk about that today. You can use your own, you can choose your own data structure, you can use it, absolutely fine. What we will focus on today is more uh, on the challenges uh, in today's industry when we are actually trying to transform complex knowledge into information or into actionable insights. We will talk about what kind of challenges do we face. We will talk about foundations. Why is it important? How to build it? We will talk about the process, and then eventually we will talk a little bit about the benefits of it. Okay, so that's actually the high-level overview of today's conversation. Now, think about this situation. Imagine, and again, these examples are important. And why is it important? Because it's easy to understand. Imagine that a sports tech firm who are active in leadership assessment and training. Sports leadership, it's a big area, right? This particular type of firms are struggling with performance data, right? So how do we help them? Our objective is actually how do we organize their information? How do we extract the insight that eventually can help these people who are the top tier sports, who belongs to this top tier sports leadership? I'm just giving you examples here. Okay, Or imagine a social scientist, people who are economists and all these people, right? They would like to do impact analysis from survey data sets. Now, survey data are complex, noisy data set. Now, question is, they are struggling with, like they are spending long hours in terms of processing the data sets before even they get to find the impact. And a lot of times, post analysis, they figure out the entire plan of the project was not meaningful in terms of impact, which means the impact was not there. How do we help them to surface these kind of situations way before the investment has happened? That kind of process, analytics oriented, deep and heavy workforce automation is something what we intend to do as part of Cinter, right? So that's what we like to do. What eventually we want to do is, we would like to empower these small and medium businesses, these SMEs, with big enterprise level tool. That's actually the end goal of this. Okay, kind of like that's what to expect from this presentation. Okay, now moving on to the next one, and here I will give a little bit of introduction what Cinter does. I will also show you one of the product, because we have a couple of a few product lines, but one of the product that we will be using to demonstrate what I mean, what I'm talking about today. Okay, so I will try to get there quickly. Okay, so as I told you, at Cinter, we are all about empowering SMEs, which is nothing but small and medium enterprises, and we do it with innovative AI solutions. That's what we do. Okay. Now, one of the product lines in our case is, think about it as Codera, which is given here. So Codera is specifically for enterprise softwares, but it's an example which will help you to understand, right? So this particular Codera cuts through the complexity. It makes workflow faster, and it is helping like small and medium businesses to compete globally, which means faster, cheaper, yet complying with the good industry standards. That's essentially what it's doing. So let's take an example here. Think about enterprise level software automation. So we automate process to uncover like basically hidden efficiencies or the process that the engineer cares. Okay, and give me a moment, because I'm going to share with you briefly. I'm going to share with you something that may help you to understand. Can you see my screen? I think it's a little bit different screen right now. Okay, I moved on from the presentation screen to a product screen, and this is actually a work in progress. So what you see here is actually when you build enterprise level product. Okay, and what I mean by that is, let's say, imagine you are building an application. As of today, what's happening? There are multiple platforms all around. For example, you have uh, Windsurf, you have v0.dev, you have GitHub Pilot. Many such software building applications are coming in. They are extremely good in terms of producing code, which is nothing but content. And if you understand how today's artificial intelligence is working, it depends on patterns. It has a vast amount of information, and it identified all the patterns. And to an artificial intelligence like a large language model, Those are patterns. What they do not understand is actually complex process. Why do I emphasize on that? The main reason is building a product is nothing but a very, very rigorous process, a process of following the good standard from this university, from the software practices, right? Here is an example. Think about it. I am building a project or a product for a company called Visya, and this is a true company, one of Sinter's client. So they are interested, let's say, high level. They will be interested to build multiple economics oriented product, and in this case, I'm just saying, okay, let's say they will be interested to build a e-commerce flow in their particular product stack. Now, once you choose that, and kind of you can give your instructions that this is a B2B facing product and so forth, then eventually what happens is AI should be able to actually process it and immediately understand that, hey, they are not only building a B2B product which is e-commerce type, but given what they have chosen, these are some of the next viable approaches. For example, they have to go for a feature and layout selection. There can be user authentication, real-time updates, file upload, payment gateway integration, processing, multi-language. It should be able to bring that process in. And at the same time, it gives you options. Third thing it does is it takes your feedback, and it also gives you examples of best practices so that you can learn from them. You can even ask your own application to follow some of those things. So as you can understand on the top, what I'm showing here, these are very, very complex procedure. uh, Organizations sometimes they have their own rules, regulations, security protocols. Everything have to be baked in. As of today, most of the AI solutions, to my knowledge, which are popular, do not follow or have the capability to follow this. They definitely give a solution, but is the solution at par with your expectation? For example, if you ask AI to write a novel for you, it will write a novel for
Sir,
it will
sorry to
write
interrupt
for,
you.
go ahead.
Can you zoom out it, please? I'm not able to. See this. Content is. The font size is very low,
Oh,
very small.
oh, is it? Can you see right now?
Yes, 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 yes. Now it is good. Thank you so much.
Okay, okay. No, absolutely, absolutely. Thanks for bringing that up. So, what I was trying to say is, I'm focusing on the process part. Why? Because writing a story, writing a novel is not the problem. The problem is what, as of today, lies is writing a novel itself is a very, very complex process where you'll have to choose characters, thematic, you'll have to do thematic analysis, you'll have to break down the story in multiple different chapters, you'll have to figure out which character have what attributes. All these things are the foundations of writing a novel. And eventually the event flow, where it gets to the climax, how does it end? Everything is part of the process of writing a novel. But as of today, it does not follow that. And that is a concern I was trying to bring in, as part of like why I showed you this particular application. There are so many complexities. You can get into application hierarchy, you can get into what kind of libraries have been used, what kind of components, and this is from the software point of view. You can get into backend, you can see what kind of database you have used, what kind of data sources you are making use of. You can also get into how do you actually plan to modernize your particular code. Those are process, and as of today the solution is not up to the level where you can improvise this process while making use of the strengths of AI, right? Basically, that's exactly what Sinter is particularly focusing on. I will pause there for a moment and see if anyone have any questions so far. Are you good so far?
Yes.
Okay, awesome, awesome. So, okay, I just want to make sure. Yeah, I'm sharing the slides. Okay, so so let's actually get back to the original slide. Okay, so I showed you in a glimpse what an enterprise software will look, what are the process involved in it. Now, this is true for any vertical, any kind of vertical. This will be true. So what I mean by that is, uh, imagine and this is one of my sports leadership client. The examples I'm giving are actually from my real clients. What they would like to do is they would like to evaluate and assess their sports leaders, and on the fly they would there are 90 different metrics they would like to evaluate on, and they would understand the gaps and create a near real-time report, which means while the person is taking the test, it will create that uh, 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 report. And then eventually, uh, there is a commercial aspect as well. If the person is willing to actually get into a deeper dive, they have a little bit of commercial there. Someone has to pay, and then eventually they get a full-fledged report. Even there, AI plays a big role, because this full-fledged report is crunching a lot of data that this particular sports leadership startup has initiated. Now, apart from that, they also want to do analytics real time. For example, they would like to see what are some of the areas people are lacking their skill set, in terms of, like, let's say, uh, 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 think about, like, intelligence. There are different kinds of intelligence. Are they lacking in certain area? Who are these people? uh, does certain organizations need certain kind of training uh, in terms uh, in terms of improving their employees leadership or their sports teams leadership? All these are something they would like to do. Now, how do you organize this information is something where we are helping them out, right? I will give you a third example here. Think about students applying for various universities. All of us are aware of it because we went through that journey, right? Ninth, 10th, 11th, and 12th, these are the 4 years. We struggle a lot. We have a lot of workload, because that's a pivotal time where we would like to know that which college I'm going to choose, what are my interests. Question is, how do we align these students with their interest and the most appropriate matchmaking universities that will be appropriate for them, for their interest, for their future goals? This is actually a edutech startup, by the way. This particular startup is from not a startup, they are already 4.5 years old, from Kerala. We are working with them to help students find their most appropriate destinations when they go for higher study. So these are the kind of problem Sinter is trying to resolve for different SMEs from different verticals. When I say verticals, it's actually specialization areas, right? So that's essentially what Sinter is doing. Now, going back in this one, now the most important question is, why is domain knowledge so tricky, right? It is very unique and very tricky. The main reason is, think about that, sports tech versus edutech. They use different terms, they use different structures, and they don't mix up easily. Even think about a more complex scenario, that the term climate, the definition or the context of using the term climate in terms of crop harvesting in agritech is different than the influence of climate on commodity trading. The same climate. That is where I think these different terms and structures are kind of it needed to be well defined and should be appropriately used given the context, right? Now, imagine a situation that particularly in, let's say, workforce management or maybe in genomics, let's say, there are certain protocols that needs to be followed precisely. And as I told you a few minutes back, AI is not good in following process, which means it cannot customize to that domain's need in terms of where it requires a very precise way of following the constraints or the boundaries of that particular domain. AI is not good in that, and that is where we are introducing a knowledge-driven approach in order to make it guided. That's what we are essentially doing in one single line, right? So imagine situations like we are trying to translate a novel without even knowing the background or the culture part of it. What happens is the details which comes from the culture in that particular novel is getting lost, and that's exactly where we are struggling. And this is an example of a complex scenario why the generic tools defined by the AI fails as of today, or let's call it this way in a more positive way, is not up to the mark, right? And this is where there are many ways to solve it, but this is where I think the graph-based approach we are bringing in is going to fix it, is going to guide it, right? So these are some of the typical examples. And now let's jump a little bit about saying like why knowledge base is the key to artificial intelligence or artificial intelligence based tool, right? So in one line, imagine that these knowledge bases are actually bringing in structured domain information. And by the virtue of bringing this structured domain information, they can introduce very reliable automation. Only reliable automation will happen if we can bring this information in, like basically the in a very structured way for that particular domain. Okay. Now, what does that even mean? It means that we precisely capture enterprise level information and we do it accurately. We represent it clearly and we leverage this information to generate insights. Now let's get a little slight technical here. What knowledge base is doing is we are building a graph model where we are connecting nodes. Nodes are nothing but entities. Imagine entities. And different nodes are connected through edges. Edges are nothing but relationships. And all these are happening from various sources, from the overall, think about overall network, or it can come from domain-specific documents. It can come from predefined rules. It can come from multiple places, right? So here is an example. Think about it this way. Like in the genomics field, think about a graph of nodes, and here nodes can be entities like human and rodents and mouse and this and that, or entities can be chromosomes and gene or gene expressions or even sequences. Everything can be entity, and they are linked with each other through a relationship. For example, 22 chromosome pairs are linked with a human, and they have distinct behavior, right? And these behaviors are actually linkage to small parts of the gene expression. And these gene expressions are tied to small sequences within that entire gene sequence, right? So each of these are very well connected. And think about it, right? Basically, this is how people say that if certain people have this kind of gene, then they will be tall versus short versus blue eyes versus brown eyes versus black eyes. All these are well connected, and our job is to structure it, right? Let's switch the domain. Let's say in sports, this graph model can look into entities like players or leaders who can be connected to certain metric, right? Basically, and then there is a relationship that if certain entity which is an individual are well connected to certain metric, they might exhibit certain behavior. You can cluster them and say, okay, these are kind of, kind of leaders they are. Without this information, AI will definitely miss the standard. Think about it, the genomics example I gave. If that, like the graphical representation where entities are connected with other entities through some relationship, if that is not there, then that means AI is going to miss the standards in that particular industry, like in healthcare, and it's not acceptable by the SMEs, right? So if we can structure this information, this foundational information can let small business access greater and deeper insights. And that's exactly what the power of this knowledge base will be. Okay. Said that, I will switch to the next slide. Now, a big question today is, what's wrong with today's knowledge extraction? Okay, and there are several. I just put together a few. First of all, imagine that there are rule gaps. AI cannot, as I told you, and this is something we all should actually get by the end of the conversation, that AI has vast amount of knowledge, AI has huge control, and it understands patterns very well, but it cannot grasp process. It cannot grasp procedural steps in domain, like the example I gave a few minutes back, right? The relationship between chromosome and gene expression, or protocols, safety protocols from the workforce management system. It cannot get there, right? What happens for that is nuances get lost, like the example I gave, like maybe in the example of making a sushi. The cultural aspect is very important, because the cultural aspect decides how the rice will be made for a sushi food recipe, right? So we cannot take away that, right? And one of the golden standard to introduce this is something called a ontology. Ontology is the key. It's a set of rules and things. We'll talk about it in a few minutes, but without ontology, it's going to be very chaotic, and there will be no real insights out of it. Make sense so far, everyone? Okay, cool. I did not hear from anyone, so I will imagine that you folks are following. If not, you can always stop me and we can actually explain or
Yes, sir.
simplify. Okay, cool. So with that, I will actually jump into the next part of it. Is uh, so how are we going to own domain knowledge, right? There are there are many ways. People have been doing this for the last 30 to 50 years almost, right? And uh, of course, expert plays a huge role here, because all these specialized tools are meant for the subject matter experts, right? Basically. So it's important at this stage that you have a global uh, ontology to start with. Then you get into conversations with expert. Then you analyze different documentation from that particular domain. Then mathematically or computationally, the ontology nodes will be defined, and ontology nodes are nothing but concepts, and the edges of that are relationship to various concepts and sub concepts. That's essentially it will boil down to. And then imagine it's like mapping subjects to values. That's what it's a good kind of like kind of corollary example. That's what's going to happen. And it has to be very focused, because ontology is the definition of what you are trying to do. And eventually it will generate graphs for reliable use, and that's your, think about it as your blueprint for that particular domain, in that, for which that ontology is going to be used. For example, in the edutech field, imagine you need to know the the uh, the process of how college admission goes through. You need to understand something like a schoology, where the circulars of different educational standards, their courses, their curriculum, all these documents and information will be the key when we have to build an ontology for edutech. Otherwise, whatever insights we will generate is not as per the SME's expectation or subject matter experts' expectation from that field, right? And by doing that, we will ensure accuracy and reliability. That's actually the goal here. Now, little bit digging more into the ontology part, a good way of visualizing ontology is like Lego blocks. Legos, as we know, those are nothing but small foundational building blocks for knowledge. That's the equivalence of that. So it's a building block for knowledge, right? And imagine it can be actually certain concepts. Let's say let's look into the pizza example. So imagine it could be the dough, right? And then there can be multiple kinds of dough, which is nothing but the properties coming in. And then it is related with something like what ingredients go through it, right? Basically, that's how it is going to connect to another concept, which can be a vegan concept, or a vegetarian pizza concept, vegetarian concept, or a non-vegetarian concept. So these are different concepts, and they are linked through certain relationships, and it could be ingredients as well there, right? And now eventually what it will result in, it will form a network and a bunch of properties and attributes that's defining each node. In this case, node is actually the concepts. At the same time, the relationship and what those properties mean there is something, the simplest way to encode domain process and their understanding. That's how you capture the whole information there. So that's actually, in nutshell, how ontology plays a role in kind of like forming the knowledge blocks and integrating them in a meaningful way. You can bring in custom rules, regulations there as well, and eventually your downstream analysis and everything will be guided by that. And when I say downstream, it's nothing but actually what you actually do it for the knowledge, right? Now, to touch base a little bit, so by now, what we got is structure is everything in ontologies, right? And this will prevent from information chaos. This will prevent any kind of confusion between stakeholders. It will eventually turn data into insights. uh, Otherwise, like when I say data, it can be multiple data set, it can be even rule based data that the organization follows. Otherwise, it will be impossible to actually incorporate them. Standard large language model and all this stuff are not capable of doing that. So we will have to bring it in a more structured way, right? So that's essentially what this slide says. uh, uh, you know we all face data ambiguity on day-to-day basis. One way to solve it is actually making use of ontologies. Now, the popular topic, large language model. Now, it's very powerful, as I said. uh, it understands the whole internet basically when they are trained on it. And I'm not getting into the details of the model size and how much it knows and all this stuff, the architectural part. But overall, it knows a lot, and it understands the pattern a lot. It even understands domain language. However, it requires guidance. A lot of times what we have seen is, most common thing is it hallucinates because it has too much of information, because it does not have guardrails. It ignores rules, protocols, but it will always give you an answer. And that's where I think ontology comes to play. We control these models through ontology, which is nothing but a guardrail around it, what to do, what not to do, and what to enforce and what to relax, all this kind of information. So so imagine a simple scenario, right? LLM, large language model, you are using to process some text, some information, but at the end of the day, ontology is something which validates the outcome and makes sure that we do not have nuances in that outcome. That's exactly, if we can actually balance these two processes, the strength of LLM, knowing a lot, knowing global things, and ontology bringing in the nitty-gritty, very localized information. It's something, I'm tempted to say optimization here, because in a lot of optimizations we do that. We have global and then we have local, and a hybrid process is always a good winner. And in this case, the same. We combine the strengths of LLM, we combine the strengths of ontology, and I think that is a win-win scenario for the subject matter experts. Now, here are a few examples. I wanted to actually show a bunch of things, like basically, you can start with simple scenarios like pizza, where you look into the hierarchy of pizza making. Or you can go into more complex scenarios like the it's called the atomic design methodologies for UI development. So this is a very software-ish, computer science-ish topic, where when you build application, your user interface is very critical, because all the user experience, this, that, everything has to be baked in. But once you have a clear observation from it, you eventually try to design it using an atomic theory. What it literally means is you have page information, and it can be multi-page application as well. And for each page, you have a concept of organism, you have a concept of molecules, you have a concept of atoms, which is the most foundational unit of it. And each of these are connected. Not only that, each of them have properties what users can manipulate or choose to kind of like explain. And this is where I would like to bring up, right? And I'm pretty sure some of you or a lot of you actually make use of chat gpt or gemini or maybe kind of like more sophisticated tools like windsurf or v0.dev or all these things you use to code, right? Now it gives a code and sometimes it runs, but if they don't run, we spend a lot of time actually trying to debug it. The main reason is we have less control around the process how that particular code was generated, and that is where we need to bring human first in control while AI is assisting it. And in order to do that, we need to introduce the process. And one of them is actually atomic theory, basically the atomic methodology, where you know which portion of your software in the UI in this context you would like to change, you would like to manipulate, you would like to modify, and you should have full control on that. In that case, your understanding about the product will be much simpler and you have full granular control. And this is where I would take a moment to briefly share with you. Maybe can you see my screen where I am showing actually? This is the best software I saw, which I like personally. That how it is being visualized. This is not my particular JSON visualization software, but this is something I am just using it from internet. Imagine in Sinter, what we are doing is, let's say you are doing atomic design methodology, UI, that's the example I was giving. In this whole process of ontology generation, you need to have version control, timestamp,
Santanu, make it
and
bigger. Zoom it.
oh, can you see it now?
Yeah. Now okay.
Okay. So some of these parameters are important because version control going forward will be important because you would like to uh, build on the top of your existing ontology going forward, and you need to actually keep track of what have changed, what has been updated, and so forth. Now, a few more things which I'm showing you at the bottom before I even get into the concepts are actually things like what kind of strategies you are adopting in order to update your ontology or build your ontology. And this is where small kind of like traditional machine learning on the ensemble techniques may kick in. For example, in this case, I'm showing you comprehensive strategy. There can be hierarchy based, there can be majority voting strategy, there can be even weighted value driven strategy. There are many strategies. That's a whole different topic which is covered under the ensemble things. This is to say that I am capturing, because remember, LLM knows a lot. The answer LLM gives you has some randomization. You can control it through some parameterization at some point. However, it's impossible to make LLM steady unless you have certain strategy as part of your workflow where you can guarantee some sort of stable outcome every time you run it. And this is outside LLM because LLM does not have this capability. For example, why LLM cannot? Because imagine I told you LLM does not know how to follow a process. LLM does not know how to do a recursive algorithm. It's not baked in as part of the large language model. It cannot do as of today, right? So you'll have to actually take care of this. Now, going to the nitty gritty, look at the concepts. For example, in this case, atomic design, it identified two main concepts, and let's break it down. What are the two concepts we see here? The first one is actually that you will have to start from the system level, And it talks about the rationale, it talks about attributes, relationship, examples. In this case, think about what is a overall UI based system. Think about a login system or a dashboard page or something like that. That's what you'd like to build. And then there are sub concepts, and this is how concepts and sub concepts are related to each other. And again, I'm revisiting what I said few minutes back from the graph definition. And here are some examples and look into some of the things. For example, even a dashboard page can have things like organism, which is the next level of granularity. It's a self-contained UI entity. And again, there are multiple attributes here, and we can go through that separately, or I can share this with you folks if you want. But the rationale is organism is the building block of the system. The system is made out of a collection of organisms here. Now, and again, this is all from the UI point of view, right? Now, that organism has sub-concept called molecule. And a molecule is a self-contained UI component, which is actually a building block for the organism. What it means, an organism is a collection of molecules. And a typical example of that is a button on the web page, or the login page, or the dashboard page, or a input field where you provide your input. Those are the typical examples. And then the ultimate smaller granularity is called atom. Atoms are nothing but actually the most fundamental unit that cannot be broken further. However, you can integrate libraries and all this stuff into atoms, but atom is the lowest granularity. Typical example for that is text or image. What you have given, what you can do is you can change the property of the atom, but that is actually a typical, think about it, it's a logical flow. And why I said that is, using this approach, you are able to capture the whole concept of building a UI system following atomic design theory using an ontology. This is the ontology that will come into play when, let's say, one of you are trying to build a dashboard showing the sales trend. Exactly, it will follow this kind of system. And as you can see, there is a relationship, there are attributes, there are kind of like co-concepts. All these will play, and this will bring you systematic, this will enforce systematic foundation, at the same time more reliable outcome. This is one example I gave. Now I will give you a second example which may be interesting, and I will make it little bit bigger. Let's say you would like to do a genomic diverse genome project. It's kind of like something I am interested in, and I'm not saying I have done it. I initiated it, but it's not going very well. I need people in Africa to support me on this. So today's scenario is that the genomic references are mostly Europe-based, whereas humanity or the humankind was originated from Africa, and less genome presence or genomic features are from Africa are present in today's genome reference. So the whole initiative was, can we actually do a pan-Africa diverse genome initiative? That's something I wanted to run. But most interesting part is, let's look into the ontologies that it came up with. Is definitely think about it this way, that it goes to the DNA and then it goes to the chromosome. Chromosome is we know 22 chromosomes we have as a human, and then it gets to the gene, then it gets to the promoter, which is nothing but the region of the DNA, and then eventually it goes to gene expressions and so forth. So now this is actually capturing how exactly genomics defines the relationship of its different concepts and sub-concepts, right? And this is a good start for the SMEs. I'm not saying that the process of capturing ontology has been solved, because a lot of times kind of like experts, domain expert plays a big role. But but what we did was we were able to come up with a robust, stable structure that can be a good starting point for the SMEs. Okay, so these are some of the things I just wanted to quickly share with you. Now, with the interest of time and what I have promised, we will move forward. Now, what is the takeaway from this is, like, let's talk about a little bit about the value chain here. So so think about it. We need to bring in a structure, and structure will help us to win. That's number one. Then precision will always beat generics, because that's what SMEs care about. That's what aligns with their thought process. And then the third thing is compliance. So what it means is align with the protocols, domain rules, or some organization specific rules. Everything should be baked in. The fourth thing, what Sinter was focusing on is, since Sinter actually serves multiple verticals, so it was focusing on the scalability. It should not be something like I spend a lot of time building an ontology for agriculture and that cannot be replicated for, let's say, social science. No, we need to come up with a process that can easily scale across multiple domains. That's something that we have done, or we are still working on it, by the way. It's not a done process. And then the advantage we get is it levels of the playing field, and for the SMEs point of view, the SMEs gain edge in their particular domain. So that's and kind of like it leads helps them to get competitive advantage eventually. Okay, so so the final piece of it is just to recap, like basically the essence of this is actually like transform different bases into enforcement, right? Basically that's essentially what this is actually talking about. So here is your opportunity to grab all the best practices from a specific vertical and encode it as part of your ontology. And from the ontology, with more domain knowledge, with more expert feedback, with more domain specific documents, information, create a hypergraph. That's what will be your guidance for that particular domain going forward. Auto validation is something where we need to pay a lot of effort, because remember, this is a life cycle, so we need to have auto validation, ongoing checks. It's a continuous cyclic loop. Then we need to bring in or ensure enterprise quality, even for small business. That's critical. And then imagine imagine a scenario that we capture the safety protocols, and we enforce actually the work safety protocols while we are building their system. That will be the ultimate success. Still going there, not achieve the entire thing, but we started with enterprise software, we started with edutech and social science. Genomics is something I have been working for long. So these are the few fields I'm trying to actually explore, because I understand to some degree, not everything, to some degree, working with multiple entities. Now, to wrap up, what essentially we are doing is so the objective is to turn expertise into our advantage, our SMEs advantage. In that way, we can actually build a reliable AI-driven system, which will take care of quality control, and which will make their business much more competitive Now, like I would like to thank all of you to actually, had the patience to listen to me throughout. And I think the next 20-25 minutes we can spend, time to actually discuss particular questions or particular areas. And kind of that's pretty much what I have as part of today's presentation. And thank you once again for listening.
Thank you, Santanu, for your talk. It's a nice talk. So now the uh, time is open for this. Time is for this question answer session. So I am requesting everybody to ask any question, any doubt that you have. Please feel free to ask question.
Yeah, feel free. And, yeah. And by the way, folks, and really appreciate. I know we talked a lot. We talked about multiple angles, and particularly me, it's my shortcoming that I'm not familiar with all of your background. But if in case you come up with some questions going forward, I think you can always grab my information from Dipankar, and you can always write me an email, connect me through LinkedIn. I'll be happy to. If you have specific problems you would like my help to solve, or if you want to discuss with me even, I'm open to that. And high level, you most likely, if the area interests you, or if you think you would like to contribute towards Center or some of the things I'm actually pursuing right now, feel free to reach out. I will be happy to collaborate, because all these initiatives are huge. It works well only through collaborations. So I'm not trying to say that I have control in everything. What I'm trying to say is most of these things, what I'm doing is through partnership. As I told you, like I showed you, like Visya. Visya is a social science company I'm working with. I'm getting their domain knowledge, encoding their domain knowledge, and helping them solve their problems, scale them. That includes writing requests for proposals as well. That's funny, but yes, that's what I'm doing as well. Automating those process, how to bring in actually a process around that, right? So yeah, so feel free to ask questions. Any question is a good question. I'm not saying that I will be able to answer everything, but I'll be happy to actually hear that first.
Any question?
Hello, Mr. Santanu.
Yeah, please.
I am Dr. Milan Basu. Lot of things you have given information, and it is very indeed a profound knowledge should require to explain it. But I have learned something from your speech. But the main thing is that while you are doing anything for oncology or anything, but domain knowledge for a particular node is very essential.
Yes.
Am I right?
That is correct. Now,
Huh.
right.
Thereafter, after getting the domain knowledge, then the relation that is age will be a great factor. But the domain knowledge, man to man or skilled person to skilled person, it may vary. So how far it will be optimized for doing the final decision? Can you highlight on this?
Yes, I think I know what you are asking. So what you are asking is, in order to build a hypergraph, we need an ontology. In order to build ontology, each node are very domain-specific entities. The edges are relationship that comes only from subject matter experts, and within subject matter experts, there can be variation in terms of who thinks what. right? Because there is a wide range of variability. Now, the question is, how do we stabilize? First of all, how do we create the ontology? The second thing is, how do we stabilize that? Something which we can rely on. Isn't that your question, right? Dr.
Yes, sir.
Bas? Yes. So yes, that's a very good question. That's why, as I told you, I think I may not be very explicit. So with the help of the large language model, you get two things out of it. One, you get a starting ontology in place which is stable and reliable. Because think about it, a large language model knows, if you guide it properly, it knows about that particular domain a lot, but what it does not know is actually the process within that domain. It has the patterns of that domain. So capture the concepts from there, create an ontology. That's step number one, which is the basic. Then bring
Yes.
in domain experts, let them provide their feedback, and your process will improve and see if their feedback, what they are providing, fits already in one or a subset of that nodes or relationship. If it already fits, then it will not update. If it does not fit, then it will add some property or add a node and validate it. Number two. Number three is it will figure out conflicts between what the domain expert says versus what other domain experts or documents are saying. So conflict resolution. Then the fourth one is actually very critical, that it actually finds evidences using the help of large language model to support or negate what that individual expert have given. Imagine this as you are bringing in support to establish a concept or a relationship, and you are taking advantage of the large language model to do that.
Yes.
Finally, even if we
Yes,
do
but I think that up to third level, it may be in a fuzzy state.
maybe in a what space?
Fuzzy state.
It can be. That's why ontology is actually a iterative process. It needs to be continuously monitored, checked, validated, cleaned, everything. So there is no one answer, one algorithm, even at least I could not come up with, that can give a clear final ontology. That's number one. Number two, rules changes, constraint changes every time. As we progress, we bring in more constraints, more domain rules. Things evolve. What is true today is not true tomorrow. All these things. So it's a continuous evolution. So ontology is going to evolve. But you are right. At any point of time, it is fuzzy. But
Yes.
if it
Thank you, sir.
represents,
Thank you.
yeah, if it represents the domain process to the best of the knowledge, the domain behavior properly, that's what is a good start. Right? And I can give you a small example. 10 years back, whatever the good practices of softwares were, as of today, it's very different. So the ontology must have kind of evolved over the last 10 years and kind of banking on what is true today. And it may not be true 15 years from now. So it has to evolve. But thank you for that question. That was a good one.
Okay, sir. Okay.
What else? Please, anyone, don't be shy. Just ask or reach out. Reach out to Dipankar, reach out to me. I'm open to conversations.
The conversation must be direct. It's no via. So
No, I'm
they
saying,
can mute yourself and then they can ask question. Anybody can ask
yeah.
question.
Anybody can ask question, and yeah.
Hello,
Hey,
Mitul here.
Yes.
Mithul,
Yeah.
go ahead.
Hello, Dr. Das. Yes. My question is the topic is and the delivery was excellent. The thing is that I'm thinking that how ontology can remain relevant without losing consistency and interoperability in this changing scenario, because you see the knowledge and technology are constantly evolving. So in this scenario, this is critical. And secondly, as you are saying, at same term can be used in different dimensions. Suppose I am saying load. For construction worker, load is something. For electrical engineer, load is something. So how would you like to address this?
Right. So you asked actually two questions here. The relevance, the interpolability. So as I said, I think it ties a little bit towards the first question. So at any point of time, so ontology is a process that evolves every day, right? And it has to go through an iterative process. There is no, think about it like in optimization, we say it's not possible to achieve global minima. Ontology is something like that. We can never achieve the global minima because it's continuously evolving. And as I mentioned, the ground truth changes, then it should evolve and get there. What we need to make sure about is we have the foundation on the top of which we reiterate and build. It's not replacing it, it's actually building on the top of that, finding the progression. It's kind of like capturing the trend. That's the first answer of the first question. But still there is a variability. Over time it's going to change all the time, all the time. That's the ground truth. Now the second part of the question was uh, the context. So ontology is the definition of where or which part of the domain. So basically ontology carries the definition of that, right? So I gave the example of the term climate, right? So if you define an ontology for commodity trading, the definition of the climate, which means the relationship and its sub concepts and their relationship and their property, will be defined for that specific task in that domain only. Let's say commodity trading, right? Which involves climate as well, right? Whereas if you switch it and say climate on harvesting, then the definition and the context of that same term will change and ontology will capture that it is saying that with respect to this climate, when the harvesting should happen, which crop kind of like is more appropriate to harvest at which time of the year, because of what climate. All these things are captured as part of the process. So that's the expectation, that ontology captures the definition and the context of that word or the term within that definition, right? And it's not true globally. That's why it is important to define a specific ontology for specific domain for which it is being used. Hopefully that gives a little bit of
Yeah, thank you. Thank you for the explanation.
what
Any
else,
question?
guys. Everyone, right? Listen, this is 15 minutes to 3 in the morning, so I'm here waiting for your question. Okay.
It's a really odd time for you, but again, thank you.
No, Dipankar, no, I think it was fun talking to everyone, and hopefully, like someday we'll actually catch up in person as well.
Yes, yes.
Any last minute
So,
questions? We have like 12
uh,
minutes left, so
yeah,
we can
12
do a
minutes
couple of
left.
stuff, right? So we
Yeah.
can actually either ask questions or let me see. I think let me check the chat. Did anyone send anything? Mm, you can post your question as well if you want, or else I can give you these 10 minutes back in your life.
Uh, do one thing. If you don't have any problem, you can share some of your experience at NASA.
Oh, I can do that. Okay, so post my PhD, I joined NASA Ames Moffett Field in California. Um, a couple of areas I used to work on, and maybe we can have a talk or something related to that. I was not ready to actually present it, but I think some reinforcement learning, which is IRL, RL, are very popular nowadays. So I worked on that around 2010, 2011 ish at NASA, and couple of initiatives I used to work on. One area was aviation safety, right? So, and then the second area was more on the uh, astrophysics side, which is a project called Kepler. Kepler was a telescope that was looking into 158,000 stars and their family. So the whole objective was to find out Earth-like planets, which which stars have planets that can potentially be Earth-like. So two different flavors, to be frank, and I will share. Uh, Start with the simple one. Um, Aviation safety. The specific area, it's a huge field, by the way, a specific area where I used to work on, because I was part of the computer science group. So I used to build algorithms that used to correct human errors, and humans are prone to errors, they make mistakes, right? There are many situations. For example, I may not be in the correct mental state, I may not be in the I may not be well versed, I may not be knowledgeable about flying the aircraft, I may have I may be forgetful, I may be ADHD issue, I may have flipped the wrong switch. So all these thing happens, right? And here is a scenario. Let's say when they are about to land 5 miles from the airport, they configure the whole aircraft. That's what pilots do. But then in between, they realizes that some of those configurations were not timely or not properly set. So these algorithms, which I particularly worked on, uh, will actually figure out what kind of mistakes humans have made. It did not capture the latent. Latent means, I'm just giving you something. If someone did not sleep last night, and that's why they are making the mistake, it could not capture that. But it will capture the mistake and immediately give a remedy. For example, if the configuration is not right and the algorithm thinks that the aircraft is going to have a hard landing, it will ask it to change the configuration, make a go around, and come back with a particular setting so that it can have a smooth landing. That kind of thing, right? Basically, or maybe it can say, use your flap, make your flap in this angle, and all this stuff. All these are details, right? But the fun part, let's talk about the fun part there. Yeah, algorithm is the fun. But the more fun part, according to me, at least the way I enjoyed it, is I had the opportunity to work with many, many pilots, because these algorithms, are algorithms, right? They are actually some sort of logical flow, mathematical representation, but at the end of the day, it should solve human problem. So human is important for me. So I used to talk to a lot of pilots. I used to kind of like get their understanding how they fly. That's number one. And then the second part of it is what kind of actions they take when they realizes that some mistakes have happened, or something corrective needs to be done, corrective action needs to be done. And I'm going to share something funny and equally scary, by the way. So sometimes they reset the whole system. What it means is, for a few seconds the aircraft is free falling, we don't realize it because it's in a motion, but they do reset, and immediately the system starts and kind of like get to the proper thing, right? So that was like great, I loved it. But the most interesting part for me was working on Kepler. It was a very interesting experience, and I will tell you how it showed up. So the principal investigator of Kepler, his name is William Buruki. Okay, and he's a famous guy. He's always on media, always on television, and all this. He used to be. Now he retired, I'm pretty sure. Uh, William Buruki called me one day, and he said this problem. He said, Shantanu, when I went to Paris and we were talking about some of the planets that has been discovered, a journalist asked me a question about something. And in order to answer that question, it took me 14 days, because 158,000 stars and their data, it's a lot of data. It's a huge, big data problem. And I said, okay, Bill, what do you want me to do? He said, okay, let's do some build some system that will analyze all the data coming from the stars and stars and the transitions, by the way, because the planets are moving around the stars, right? All the transition data and everything, and there are signal processing, blah blah blah, all this stuff are there. So eventually, here is the fun part. I never thought I will accomplish this, and I was lucky, by the way, to get in touch with him. Uh, we built a system which is nothing but a distributed Kepler's law. And that is something I never thought I would do in my life, right? It's a distributed Kepler's law, and that can run in a few hours. And because it's distributed, so it uses the entire cluster, which was my contribution. But I had to understand the Kepler's law. I need to understand how they ingest the data, and kind of like distribute the job such a way that the end result of the Kepler's outcome was approximately very close. So I think that was a very fun kind of activity. And then the second thing, what he told me was, imagine the Kepler, the telescope is already in the space, so nothing can be done, right? How do we increase the signal to noise ratio so that the mission length can be virtually increased? And that was a very interesting concept. So what we do is we increase because instead of 5 years, if it stays there 7 years, what is the merit of that mission? At the end of the day, that was the question he asked me. And then that's some work I did on, it's called merit function. I built some merit function that shows that if we bring in this kind of signal processing related changes, and it's very complex, by the way, because this Kepler thing had so many panels at different angles, and they switch on, switch off, some of them gets damaged, some sensors are, so it's a lot of complicated stuff. Basically array of sensors, think about it that way. So how do you actually create this merit function that actually tell you, instead of 5 years, if you prolong the mission for 7 years, how many new planets you will discover, how many new Earth-like planets most likely you will discover. Kind of like it's a probabilistic way of saying it. And by the way, so basically Journal of Astrophysics, I was lucky to have a paper with William Buruki. Never thought that I will get one, I should be honest. But yeah, those are some of the fun experiences. And then, after 6-7 years, I eventually moved on. That's kind of the thing. Yeah.
Excellent,
Sir,
excellent work.
excellent information, sir. Mr. Santanu, lots of thanks to you. You are sharing with us, and we are very glad to accept it.
No, I think it was very, very fun talking to all of you. And again, as I told you, I'm very obliged and lucky that I got the opportunity to talk to all of you.
Yes, you have got the opportunity.
Yeah, feel free to.
By virtue of your charisma and efficiency also.
I think it's mutual, by the way, because I think a lot of good folks I'm getting in touch with. Please feel free to connect if you have specific things you would like to solve. I'm not going to steal it, by the way. I'm going to help you out or get some understanding. So feel free to connect, and I'll be happy to, because I love collaborations.
Okay, sir. Okay, sir.
Okay, I have a very specific question. Initially, you told that you have distributed the Kepler law and achieved something. Means in order, means
Answer some questions.
initially it was suppose centralized, and then you have make it distributed. So in terms of time, what type of achievement you have done? Means earlier it was giving result in 14 days. Now it is giving result in how many days?
No, it's hours, not even days, because don't forget that two people in US, not two people, two organizations in US have the best clusters. One is Palantir, another one is NASA. They have the best cluster, processing cluster in United States.
Okay.
So
now it is giving in hours. Earlier,
Yes.
before making it distributed, in how many hours it was giving its result?
Oh, it was close to 2 weeks. That's what his problem statement was, and that's when I was called. That's when
Now
I was.
it came down to few hours.
Yes, yes, and
Okay.
massive but the thing is that here is the important part. See, distributed coding and all this stuff or computing is not new. A lot of people are doing. If you think about
Yes, yes,
Databricks, they are big time. They are very good in that. Okay, I worked with
yes.
Databricks as well. But here is the thing. Did I ever think as a person that I will one day distribute with someone, distribute Kepler's law? Come on, right? I was hardly remembering Kepler's law, and now I had to distribute it, and that was like a lot of fun. And I shared it because it was a lot of fun for me.
Yes, yes. It's a really achievement, big achievement to everybody. Means,
It's good. It's good.
okay.
Yeah.
So I think there is no more questions from anybody, and I think we are already 3:30 here. So initially, when I talked with Santanu, I know he is a very busy person, and probably he is now collaborating with more than 10 companies. Am I correct?
Yeah.
Now you are understanding that how the busy person he is. So still he has given time. 1.5 hours is not very less, and from his talk we know many important things. So it's a nice session again. Very much thank you to you. So
Absolutely, absolutely. See,
okay.
do not worry if I am busy or not. I may be busy, but not a useful person. But I think with collaborations, we can do a lot. So feel free to
Yes.
connect. I actually gave my email ID, personal email ID, and my LinkedIn there. Feel free to reach out, please. I think it will be an honor at the same time, a good opportunity for me. Someday, I don't know when, maybe in December or maybe around that time. When I will be in person there, I'll be happy to actually visit all of you.
Yes, yes. Okay, so thank you again, once again. And it's time to move to the next session. Next speaker is already there. Okay,
Awesome.
Dr. Arpit Yadav. Okay, so may I move to the next session?
Please go ahead. Thank you so much once again. I will switch off my camera and thanks again.
Okay, thank you, thank you. So let me first introduce Dr. Arpit Yadav. It is my honor to introduce Dr. Arpit Yadav, a seasoned researcher in artificial intelligence and machine learning with over 17 years of expertise. His works span generative AI, deep learning, natural language processing, data analysis, AI ethics, VLSI architecture for AI applications. Dr. Yadav is a recognized international speaker and has successfully led consulting project with include leading global organization including Oracle, Walmart, Ericsson, Deloitte, Genpact, Flipkart, then Bank of Baroda, Time Educations. His contributions focus on building end-to-end AI solution from predict analysis and NLP automation to RAG-based systems, responsible AI frameworks, and enterprise scale AI adaptation. We are privileged to have him with us today. Please join me in welcoming Dr. Arpit Yadav to deliver his address. Over to you,
Thank you,
Dr.
sir.
Arpit Yadav.
Thank you, sir, for the kind introduction about me. Please confirm that my voice is clearly audible and my screen is visible.
Yes, yes, no problem.
Thank you very much. I'm starting my session. A very good afternoon, one and all. I welcome all of you on our wonderful sessions on the topic called as the world of generative AI. And we are going to witness today that how generative AI topic is transforming our business and the society. First of all, I would like to thank Dutta sir for inviting me as a speaker in this FDP session. And I'm very much thankful to him. Before starting the main session, I would like to say one very important thing to all the participants, those who are listening to me currently. Concentrate on my wording very carefully. As a learner from the various background, either technical background or a non-technical background, In the technical background also, you're a learner from the various branches. Suppose in the engineering, various branches, mechanical, textile, civil, computer science, electronics, and so on. Whenever we people are deciding to upgrade our skills in some new technology, so please don't directly jump to learn that technology. Then what to do? Before learning any new technology in the market, please ask 3 questions to yourself, and you should have the answer of all those 3 questions. What are those 3 questions? The very first question you are going to ask yourself is, what is this technology, topic under those technology, and the tools under that topic? 3T. Technology, topic under that technology, and the tools under that topic. And why there is a demand in the market. We should know the answer of this. Second important question is, why all multinational companies, government organizations, and the small scale company are using this technology, topic, and the tool? And with the combination of these 3T, what are the different applications they are building for the society? And we as a common public are using those applications in our day-to-day life intentionally and unintentionally. We should know the answer of this. And a third very important question is, as a single individual, what are the skill set required to learn that technology, topic, and the tool? And once you upgrade that, as a single individual again, what application you will build for the society? And after building those applications, obviously you will be optimizing your career and so on. So I will be giving the answer of all those 3 questions in the very easy way and in the quality way. My name is Dr. Arpit Yadav, and I'm the CEO of Agentrix, and also I'm working as a Chief AI Scientist at CDE Bangalore. So let's go ahead. So in future, their digital twin technologies of the digital twin, which is called as a AI avatar. After the end of the session, I will guide you how to make this. So this AI avatar, I made it 2 years before, but today there is so much advancement in the generative AI technology that AI avatar will look like me only. That is a generative AI avatars. And with the help of this technology, one person can present at the same time 1,000 places in the different corner of the world and speaking on different topics. So this is possible with the help of generative AI nowadays, and I will guide you how to make it ahead. But before starting, I would like to say something about me, as I am consultant and research and development at various companies, Oracle, Walmart, GenRAIT, Flipkart, and I'm also a mentor with the reputed universities across the world, IIT Guwahati, IIT Jodhpur, IIT Mumbai, BITS Pilani, Geo Institute, Golden Gate University, USA, Cambridge, Kellogg, and so on. So I'm a mentor in that all university where I'm guiding the participant to learn about the AI technology and how to use in the business purposes. After that, whatever the work I am doing, my work is divided into 2 major parts: research and development design products in the vertical of AI, and also consulting project for solving different business problems of different industries, healthcare, automobile, insurance, finance, and so on. So whatever the learning I'm taking, so it's my duty to pass on to the society. So I'm mentoring multiple universities, corporates, so that I am giving the training to them to learn all this technology to build applications. So I'm a global level speaker in the vertical of data analytics, machine learning, deep learning, and AI, and I'm giving the guidance to them. Finally, whatever the small contribution I have done in this field, I have been rewarded with these 4 awards as a researcher. I have been awarded as a researcher. I have been awarded as a best corporate deployment process, guiding the companies and the university. And I also have been awarded based in the innovation, design, and the training award. So these awards motivates me to do something better for the society. So let's start today's major topic of the discussion. And I am here to guide you that how we are going to make your life easier with the topic called as generative AI. And I am a very interactive person. I am going to interact with you a lot during my session. So before again jumping into the main topic, I am having one question for all of you. Please give me the answer of this question. Lack of awareness and lack of knowledge, which is much more danger? Please give me the answer of this. Lack of awareness and lack of knowledge. Think it. And please let me know which is much more danger.
Sir, I think lack of awareness.
Lack of awareness. Okay, very good. What about others?
I think also lack of awareness.
Lack of awareness. Absolutely. Actually, both are danger, but from priority point of view, lack of awareness is much more danger. And I appreciate your answer is correct. If we people are not aware in the world of AI also, what are the recent tools company are using to make the application? If you are not aware of that, then might be possible we are not using the best optimizing solution. So the same thing now in this slide. There is one heading called as new normal in technology. Again, one question to all of you. Have you ever heard new normal word in any context before? Any context? Heard or not heard? I heard this new normal word during COVID. COVID is a new normal. Such kind of the heading I have read during the 2020 and 2021. I don't know about you, have you heard or not? So let me explain this in the very easy way. So I am having the habit of teaching the technology from the wording also. So new normal is having two words. One is new and one is normal. Break into two parts, new and normal. What is the meaning of that? Anything coming new to the world and becoming normal very easily, it is a new normal. COVID came in 2020. It was new to the world. But in 2025 today, we are habitual of living with COVID. So that's why COVID is a new normal. Same thing in the technological world. Artificial intelligence is a new normal in technology from implementation point of view, not from theoretical point of view. Again, concentrate on my wording very carefully. AI is a new normal in technology from implementation point of view, from the application point of view. But from theoretical point of view, AI is already introduced to the world in the year of 1956. AI was theoretically born. And from the year 1956 to 2010, AI was theoretically present, but practically absent from application point of view. Only where few applications were developed by some big company, but majorly it was not present in the society from the application point of view. So that duration, 1956 to 2010, that duration is declared as a winter AI. And what is the meaning of this? Winter AI means AI is theoretically present but practically absent. So when we done the research on that, so we come to know that AI is dependent on four major factors. As you are already knowing that AI is heavily dependent on data, then hardware requires to store that data and to process that data, then algorithms and software tools. So these all four factors were not present in that volume, which is responsible for making the AI applications. So hence that duration 1956 to 2010 is declared as a winter AI. Due to the absence of this four factor, AI was just theoretically present. But due to the advancement in digital technology, after 2010, the data generation increases, hardware capacity increases, and new algorithm in the world of AI taken place after 2012. Due to the four combination nowadays, it is possible to make AI application and building various kind of projects for the different industries. So on that vertical only in this slide, all top giant companies, service-based company, like top giant like Google, Meta, Amazon, Microsoft, and a service-based company like Infosys, Wipro, TCS. Whenever this company are working on AI project, this equation is the engine of that project, engine. So what this equation is guiding us? Very simple. This equation is guiding us, adding artificial intelligence to any X, we are getting business as an outcome. So today I'm going to guide you from scratch how we are building the application inside the industry and how you people can in future also build that. So again, one question to all of you. In this slide, from your point of view, what is the meaning of X from your point of view? Adding AI to any X, we are getting business as an outcome. So just wanted to check, because you are a part of AI in your day-to-day life. What is the meaning of X? Any idea?
Sir, implementation.
Smart
of AI.
implementation.
Implementation of AI. Okay, one of the answer. But again, X is something different. That's what I have chosen to explain this slide. So many people are making the mistake while developing the application. So X from your point of view. I appreciate this is one of the answer, but not the perfect one. Any other answer?
Informed decision.
informed decision. Okay, great. Okay. After that, anyone? I appreciate all answer.
Datas.
Datas. Oh, great. Very near to that. Now we are very near. Any other answer? Okay, due to the time limitation, let me give the answer. X means any industry, any education sector, and so on. For example, industry means healthcare industry, automobile industry, transportation industry, manufacturing, social media, logistic, oil and gas, and list is very big. And education sector like engineering, MBA, healthcare, that is MBBS, and so on. So the thing is, every industries are facing thousands of challenges in their day-to-day work operation, and industry wants solution for that. And now when industry is facing that problem, so industry is doing some research whether this given problem is solvable with the help of AI or not. So when they come to know this problem is suppose solvable with the help of AI, then this equation born. And this equation is guiding us that adding AI as a solution approach to the business problem of that industry, we are giving output as a solution. And by selling that solution, we are making the business. So let's go deeper in that and understand that how we people are making the business in a very easier way. So the thing is, as I told you, AI is acting as a solution approach. Nowadays, AI is acting as a tool which is used everywhere because every industries and the education sector needs some optimization and having some business problem. So what we are doing, we are adding AI to the business problem of that respective industry, and depending on that client requirement, we are giving the output as a solution, and that solution is nothing but one application. If suppose client want AI enabled mobile app for some business problem, so we will make AI enabled mobile app. If a client want make a SaaS product, AI enabled SaaS product. If a client is asking make a Alexa kind of device, AI enabled Alexa device for their business problem. If the client is asking, can you make a robot, AI enabled robot for my business problem? So the thing is very simple. We people inside the company are making one AI enabled product, that is application. And that product when public will use, so obviously that product is solving some of the business problem. And by selling those products, we people are doing the business. So X means industry. That's what AI is very famous. Every industries are needing AI nowadays. Every education sector need the AI and so on. So on this similar note, I am having something for you to explain in detail. Now please concentrate again here. On the left hand side of this diagram, healthcare industries are approaching us, for example, and the healthcare industry is asking us, hey, can you please prepare mobile app for cancer detection using AI? Okay, mobile app for cancer detection using AI. Now I am having 3 questions for you. Please give me the answer of that. In this diagram on the yellow color block, problem statement or business problem is given by client to us. Now can you please tell me what client want? What is the problem we are solving in this problem statement? What client want we to solve that? It is clearly written. What we are solving? What is the problem? Please tell me. What is the problem we are solving here? Cancer detection. Cancer detection problem we are solving. By what we are solving? By AI. And after solving cancer detection using AI, what is the output client is expecting? Mobile app. So 3 things are hidden here. One is the problem, by what we are solving, and after solving that as an outcome, what client want? Mobile app. More the download of mobile app, more the business. Now to solve this problem, what we are doing, AI is acting as a solution approach, and we are adding AI to that cancer detection problem. So we will take the data of that cancer. We will take the data of that cancer. Now, as I shown you my background, I am completely from the technical background. And if suppose some healthcare industries are approaching to solve this cancer detection problem, so we are taking that. But there is one problem here. When the healthcare company will give data related to cancer to me, and I'm from the technical background, and I'm not understanding ABCD of the data of cancer. I'm not understanding that. And if I apply forcefully AI on that, AI will give output. But you only tell me that output will be productive output or a dangerous output. Tell me. If you are not understanding the data of the business problem, you are not having any understanding of that. And then you are forcefully applying AI on that. So what is the outcome? Outcome will be good or dangerous? Tell me.
Obviously dangerous.
Obviously dangerous. So here we stuck. We cannot solve this business problem until and unless we have the knowledge of that cancer data. So what is the solution of that from your point of view? To understand the cancer data, what should we need? Any idea? Very simple answer. We need someone who can explain us the cancer data. And who is that someone? Domain expert or a subject matter expert? Doctor itself. So we are hiring doctor as a subject matter expert to help us to understand the cancer data. Hence, domain knowledge of the data is extremely important in the world of AI. And then finally, this equation is available. To make a successful business in the vertical of AI, we need two people. One is the person AI, which is having the knowledge of AI, and one is the domain expert of that field, who will going to explain us the data and a complete deep knowledge about the data. By combining these two processes, we are deciding the strategies and we are making the application. So hence, subject matter expert, that means domain knowledge, is extremely important in the world of AI, and we cannot solve any project without domain knowledge. Hence, everyone is 50% ready. Suppose if you are having 30 years of experience in some manufacturing industry, and now AI came from last 10 years. So it doesn't mean that your job is in danger. You are already ready with the 50% manufacturing industry domain knowledge. If you are using AI just as a tool to solve the business problem of the manufacturing industry, obviously you will make a good applications. So you people are 50% ready, those who are not from the field of AI. So you are 50% ready with the domain knowledge. Use AI as a solution of it. Now once it is done, so we are solving the business problem of so many industry. AI in the biotechnological industry for DNA analysis, molecular analysis, and so on. We are making the agricultural business problem with the help of AI. 24/7 drone monitoring, mobile app for plant disease identification, mobile app for soil monitoring, robots for fruit is ripe or not. So we are making this various product, AI enabled product, and by selling those products, we are doing the business in the market. Similarly, in the electrical vehicle industry, vehicle to vehicle communication, object detection, EDAS system, optimization of the battery with the help of AI. So many things we people are solving in the electrical vehicle spectrum. And after that, humanoid robots are coming. Task-specific humanoid robots. 2025 year, this year is declared as the year of agentic AI. If you heard that. Whereas 2027 is already declared in advance the year of humanoid robots. So we are bringing humanoid robots for the task specific. So that robot will solve that task. Similarly, we are bringing the pets, humanoid pets, to solve the different tasks and so on. So that's what we people are doing in the vertical of AI. We are making the entire product for the task specific, which will solve some business problem and make the business outcome. So the thing is, what we are doing, I will explain you the AI in the very easy way. So we cannot directly learn the AI. So these are the AI in nutshell. As a scientist, depending on the business problem, we are applying the solution approach. And this is AI in nutshell in one slide. And I'm going to explain within 5 minutes that when to use what part, so that you can understand the generative AI topic today, from where it came. There is a dot connection. We cannot directly jump to generative AI. So I'm going to explain this slide in the very easy example. First of all, let me explain the word of AI in the easy example so that you should not forget, and you will not forget it. Check it. How many word AI is having? 2 words. One is artificial and one is intelligence. Break into 2 parts. So artificial and intelligence. What is our duty inside the company? Very simple. Our duty is to provide intelligence to the machine artificially, to create the intelligent machine which will take a decision like us to solve some task. That intelligent machine will take a decision by itself, think like us, behave like us, and take the task like us. So AI in the simple word means creating intelligent machine to solve some task. Alexa is the intelligent machine to solve some task. Driverless car is the intelligent machine to solve some task, and so on. So to create that intelligent machine, there is a contribution of all this. And let me explain in the easy example so that you will never forget. Because when the client is approaching us, so we want to provide a solution. So what kind of solution we can provide with the help of AI, that I am explaining now. So consider AI is your house, home, and this 7 topic or 7 are the family member of that home. These are all the family members: data engineering, data analytics, and so on. So let me explain this in the simple language. So every person is having the special power, and because of that special power of that person, we are utilizing to solve the business problem. So what is the power of data engineering person? Very simple. Data engineering person is having one special ability, and that ability is to collect the data related to project, store in the databases, maintenance and the security of the data. Again, I am repeating. What is the power of data engineering person? Collection, storing, maintenance and the security of the data. That is data engineering. Whereas what is the power of data analytics person? Data analytics person power is whatever the data collected by data engineering and kept in the database, read that data and clean that data pre-processing. So we have to do the data cleaning. So data analytics is the person, those who are going to do the data cleaning. And on the clean data, we are doing analysis. So it is a rule in the world. On the clean data only, we will do the entire analysis, otherwise not. Because there are 2 dialogue famous in the company. Quality input gives quality output, garbage input gives garbage output. So that's what data analytics person major responsibility is, to do the data cleaning. Once the data is clean, we will do the analysis. Where analysis means whatever the question asked by the client, we will find the answer. For example, you know DMart guys, DMart. Do you know DMart? Yes? Interact with me. The more you will interact, more will be the good learning. Do you know DMart? Yes or no?
Yes, sir.
So DMart. So consider that DMart is our one client, and DMart is approaching us, and DMart is giving the business problem to solve. What the DMart is asking? Hey Arpit, take my 10-year-old data and just give me the information that which product sold more from the last 10 years, which gender is purchasing more, which age group it is purchasing more, and from which region it is sold more. So DMart want to know this information from the last 10-year-old data. As a human, we cannot find that, but it is the crore rows in that, and so on. Excel is also not having that capacity to solve that. So now that's what AI come into picture, that is data analytics. Whenever client want to know any past information from the data, historical data is there, and they want to know the information from that data. At that point, we are applying data analytics as a solution approach. What this project will do, in this data engineering person will collect the 10-year-old data of DMart. Then data analytics person will clean that data. And on the clean data, data analytics person will apply some software tool like Power BI and Tableau for data visualization. And we will find the answer of the question. Data analytics person will apply Power BI tool on the data to find the answer of first question. Which product sold the most? So in the data product column will be there. We will apply the tool on that. We will get the graph. And that graph will clearly give the answer which product sold the most. Similarly, gender column will be there. We will apply the tool on that. We will get the answer which gender is purchasing the product more. So like that, we got the 4 graph as an answer. Now I want to ask one question to you. If you are a DMart owner and you have asked me this question, and I am giving you the answer of this 4 question, that product A sold the most, female is purchasing the product more in the age group of 20 to 40, and in the south region it is sold more. So one quick question to all of you: if you are a DMart stakeholder and a owner, what you will do with this information? First, product A sold the most. So what decision you will take? You got the answer now. That product A sold the most means product A is the favorite product. So what you will do? What action you will take?
I will increase the production of the product A.
Absolutely correct answer. We will increase the stock of that product again, because more again that product will sold more. So what is the learning we are learning from here? Data is giving you business. The journey we are learning currently, converting the data to business. DMart is having the historical data but unclean data. There are so many information hidden inside the dirty data. That's what this AI picture is coming into the world, that we are finding the meaningful information from the dirty data on the basis of client questions. So this journey is called as data analytics, converting data to business. So when any client is approaching you, they want to know only historical data information, what is hidden inside that. Apply data analytics as a solution approach. Now, let's move ahead. When to apply machine learning and deep learning? So let me explain with the same example with DMart. Again, DMart approaches us. Now DMart is asking, hey Arpit, do one thing. Take my 10-year-old data, and can you please do one thing? In that data, there is one sales column. Please analyze the sales column and learn the pattern of the sales. And can you please predict next 1 year sale? Prediction word is coming now. So whenever prediction word is coming into picture, we are applying machine learning and deep learning as a solution approach. Same thing. Data engineering will take the 10-year-old data. Data analytics will clean the data. Now machine learning or deep learning will apply algorithm on the clean data, because it is a prediction problem. So algorithm will learn from the clean data and a pattern of that. And now after learning, algorithm is ready for the prediction. So whenever any prediction problem is coming into picture, we are applying either machine learning or deep learning as a solution approach. So when to use machine learning, when to use deep learning? Answer is very simple. Whenever you are working on any project, and whenever the data related to project is either image, video, audio, text, use deep learning as a solution approach. Because deep learning is the special person which is having the ability to work on image, video, audio, text. Machine learning can also work, but the accuracy is not that great. Deep learning is having the wonderful ability of that. Hence, use deep learning when data is in the form of image, video, audio, text. Now, deep learning is having the 2 person, that is 2 children, computer vision and NLP, which is coming under deep learning. Computer vision means what? Having 2 words, computer and the vision. Vision means eyes. So computer vision means what? It is giving the ability to machine to see the world. That means computer vision is giving eyes to the machine to see the world. And when it will see the world, either image or the video. So computer vision means we are applying as a solution approach whenever we are working on the project where data is in the form of images and video. That is computer vision. Whereas NLP means natural language processing is the ability to provide machine to read, write, listen, talk, interpret human languages. So NLP means we are giving the ability to machine to talk with us, to read, understand my language. That is NLP. So one quick question. So to interact with the machines, what kind of data we needed? When I am interacting with the machine, I am talking with the machine, listening, reading, and so on. What kind of data is needed to interact with machine? Now, what kind of interaction I am doing with you? Audio. Audio. To interact with the machine, we need text and audio. NLP. So please remember, whenever your data is in the form of text and audio, and you want to build some applications, so NLP. So this is the process. Now finally generative AI come into picture. Generative AI means what? Having three words: generative and AI. AI means already I guided you, creating intelligent machine to solve some task. Now add generative on the top of that. Generative means generate the data, either images, video, audio, text, PPT, website, movies, and so on with the help of AI. So generating the data with the help of AI is called as generative AI. And now I want to show you something. Please give me your honest opinion. Okay, please give me your honest opinion. Okay, who is he? Tell me that. Who is he in front of you? There is one image. And can you please tell me from any angle? First of all, let me ask the question. This image look real or fake? First tell me that and be honest. I am surrendering. I am in the AI from the last 15 years. If someone will come and show me this picture to me, from my side, I am telling that it look like very real. From your side, any eagle eye, those who can say that this picture is a fake picture. Anyone? Tell me, is this look real or fake? First of all, tell me that. This picture look fake. Okay, oh my God. From which angle tell me it look fake? Because you are telling it is fake, so I should know the answer also, logical answer. Because I am surrendering from my side, it look very real to me. From my side, I am telling. But if you are telling it is a fake, so please give me the logical reason from where it look like fake. Anyone?
The skin texture is very
Okay.
very smooth skin texture. That's why.
Okay, might be your point of view is that, but such kind of skin texture is available in boys also. I can show that. Okay, but yeah, I appreciate your answer. Let me refresh this, and now tell me, for this, it look real or fake? Okay, so let me give the answer finally due to time limitation. This website link I am pasting in the chat window. This website name is this person doesn't exist in the world.com. Actually, this person doesn't exist in the world. This is generated by generative AI. Okay, and now one quick question. In this slide, I already told you, when we are dealing with the images and video kind of data, which is the person we are using? In this entire 7-member, which person is having the ability to work good on image and video in this slide? Computer vision. So this generative AI has generated this image with the help of computer vision. Okay, with the help of computer vision. Now let me show you something more interesting now. I don't know it will be audible to you or not, but I want to show you that. Okay, now let's check it. This application we have developed. This is also we have developed, okay, as a generative AI, and this also we have developed. This is called as voice to voice assistance, and this will talk with you. Okay, let me show the link in the chat window. I am going to talk with this device now. Okay, now this device will talk with you. I'm going to talk right now in front of you. Now let's check it. Hey Mark, how are you? Hey Mark, what is artificial intelligence? Okay, Mark. Okay, okay. Can you please tell me where is Dubai? Okay. Can you talk to? Can you talk me in Hindi? ओके ओके अभी आप बंगाली में बात कीजिए actually this device is talking with me. I can listen to him, but due to this online meet, I don't know it is audible to you or not. Okay, it is audible to you or not, but this is talking with me. Okay, this we have developed. That is a virtual assistant in the multilingual language. That is voice to voice assistance and in the multilingual. Now see, मार्क स्पेनिश में बात कीजिए.
Is it free? Is it free?
ओके ग्रेट. अच्छा मार्क एक काम कीजिए, इटली में बात कीजिए, इटालियन में बात कीजिए. So see guys, this is called as UltraVox voice to voice virtual assistants, and we have already developed this product in the multilingual language and so on. So this is generative AI, and now I wanted to ask one quick question to everyone. Now in this kind of devices where
Is
I
it
am
free?
talking with
Is it
this people,
free?
it is free, but to call the API for building some product, we need to have purchased the API for that. Okay. And I must tell you that number one currently in the world to make such kind of voice assistant, 11 Labs API, you can use it. This is the number one currently in the world. We have tested it on the basis of evaluation metrics and so on. So 11 Labs is that product. Use that. Okay, call the API and use that. So I have pasted the link in the chat window, Dr. Partha. You can click on that link and you can talk with that device, because right now I'm the online meet in the Google Meet. Might be that device is not audible to you, but you can click on that link and check it. So one quick question to all of you: to make Mark or voice to voice assistant kind of device from this 7%, which person we are going to use? Tell me, which person is having the ability to work with text and audio data? Tell me. From this slide, I told you, I already given the answer.
NLP.
Absolutely correct, NLP. So that's what I'm saying you, that generative AI is born because of the previous only. Generative AI is using at the backend foundation models of computer vision and NLP. So that is a generative AI. So that's what this is, a step-by-step ladder to learn AI in nutshell. You cannot learn machine learning without data analytics. That means data cleaning. You cannot do data cleaning until and unless you haven't collected the data. So this is step-by-step ladder to learn AI, right from data engineering to generative AI. Now on this part, once we came to know this, so AI is divided into three parts in the world currently. AI means artificial narrow intelligence, artificial general intelligence, and artificial super intelligence. So artificial narrow intelligence means what? I already told you, AI means creating intelligent machine. Now, whatever intelligent machine you have created, our expectation is that that intelligent machine should behave like human, think like human, take a decision like human. So that is our expectation. So now we are comparing intelligent machine intelligence with human intelligence. So there is a comparison now. Machine intelligence versus human intelligence. So we come to know so many things, that currently machine intelligence are far ahead than human intelligence in many category, like faster calculation, memory, and so on. Whereas we human intelligence are far ahead than machine intelligence in many category, like we feel the emotions, we can feel the taste of food, and so on. So currently in the world, when we compare both, so we come to know that we human intelligence win the race. We are far ahead than machine intelligence. So such kind of intelligent product was intelligence is less than human intelligence is called as AWI, artificial weak intelligent product, or ANI, artificial narrow intelligence. So currently our world is going through the phase of AWI, ANI. Whatever intelligent product we are using, they are intelligent as compared to human. So chat GPT, driverless car, Alexa, humanoid robot are weak intelligent. But scientists are trying their level best that one day will come where we, that is human intelligence and machine intelligence will be equal. And that will be called as artificial general intelligence. Okay, sure, and very soon that product is coming. And so many top giant company in the world are in the race, and already they have claimed that they are working on AGI, and soon they will release the product. And last, very dangerous, one day will come where machine intelligence will overtake human intelligence, and that will be called as artificial super intelligence. Okay, so this is that process. So in this process, AI is divided into three categories, and to build the AI product, we are following this end-to-end AI life cycle. Any business problem in the world, either it is data analytics, computer vision, NLP, or generative AI. So this we are following end-to-end AI life cycle. Whenever client is giving the project to us, so we are understanding that problem. That is called as a business understanding. And with the help of domain expert, we are noting that what kind of data is required to solve this business problem. Then we are going to collect that data. That is data engineering team. That is a dirty data. Then we are going to validate that data, testing of the data, whether it is coming from the reliable sources or not, whether it is having biasness or not, and so on. Once it is done, then we are doing heavy data cleaning. And after data cleaning, we are applying data modeling as algorithm, computer vision or machine learning or NLP and so on. And we are changing the hyperparameter of that. That is model tuning. So here, now algorithm is learning from the data. That's what it is called as a machine learning and deep learning. And it will give model as an output. So that model is used for prediction. That model will do prediction. That prediction is correct or not, is working good or not, it is done by with the help of model evaluation metrics. And once satisfactory evaluation metrics results are there, we are deploying that model to the common public. So that prediction will be good. And then we are doing the model monitoring. So all this we are doing under one rules and regulation called as AI ethics. Responsibly, we are following all the protocol and releasing the product. So this is the process in end-to-end AI lifecycle. So whatever we are doing, so we required hardwares. So either we are having the two options. Our own company is having the in-house infrastructure that is called as the on-premises. So we can put our entire data on that. But if you are not having the in-house infrastructure, so you can go for the cloud. So from scalability point of view, there are the two options, in-house and cloud computing. So for scalability point of view, cloud computing is always good. Because in-house, we are limited by the hardware, we require upgrade to the procurement department, and it is a long cycle. In the cloud computing, within an hour, you will get the hardwares. Maintenance, if you are going for cloud computing, they will take care of maintenance. You don't need to take care. If in-house infrastructure, you have to take care of the maintenance of the hardwares and so on. In AI/ML integration, there is a long setup required in all the hardwares of our in-house infrastructure, whereas in the cloud computing, easily on-built AI access, we will get it. Availability and uptime, obviously, if you want in-house infrastructure, it is a long time to set up that, whereas it is easily available and uptime is 99.99. That means all time it will be available, it will not go down. But if our system goes down, it will be a long time to make it up. And from the cost, cloud is less costlier as compared to the on-premises. So this is a data analysis process. That is hardware part. On the basis of that, when we are going for generative AI, so generative AI is having these four major outcome. That means component. So if you go on through that AI in nutshell, so generative AI at the last, generative AI at the backside is using foundation model of computer vision and NLP. And to learn generative AI in detail, so these are the four major components of generative AI: prompt engineering, RAG, fine-tuning, and AI agents. So you are very much aware about the prompt engineering. Prompt means what? We are asking question to AI tool. Okay, we are asking question to AI tool. Based on our question, AI tool is responding. Okay, so it is very necessary that you people should learn the rules and regulation of prompt engineering. But many of us don't know that. That's what I wanted to show you something. I'm actually guiding across the world all these basic rules and regulation of prompt engineering as well. Okay, and let me show you something, that prompt engineering is following certain rules and regulation, and that is called as a protocols, frameworks of prompt engineering. That framework look like this. I will show you something. Just a second. Prompt engineering notes, and these are all prompt engineering. See, mastering the art of prompt engineering, 6 to 7 frameworks. Okay, framework means what? In what fashion you should write down the prompt. Your context should be clear, objective, role, and example. That means whenever you are writing the prompt, you have to set the context. Who is the audience? What is the background of that? You need to write down the objective. What is the goal of that prompt? Then role. That is role-based prompting. Act like a doctor and suggest me the medicine. Act like a lawyer. Can you please let me know the law? Act like an engineer. Can you please suggest me like that? Then ChatGPT and other LLM acting like that. That is role-based prompting. And give the example. So I want to show you something very important, which you like it a lot. So when we are coming to this ChatGPT, and I am writing the simple prompt in front of you, check it. What is generative AI and its application? Like that, you people are interacting with the LLM in your day-to-day life. Okay, AI tools in the day-to-day life. So I have written this prompt. On the basis of this prompt, I will get the answer. So it will give me the answer on the basis of this prompt to me. Check it. Okay, done. So let me show you something very good and important for you. I request everyone, those who are listening me right now, please log into this website called as Prompt Cowboy. This website. Okay, I am pasting the link in the chat window, and I will show you the magic of this now. Okay, I will show you the magic. I have pasted the link in the chat window. Everyone, this website name is called as Prompt Cowboy, and that prompt which I pasted in the chat GPT is a very general purpose prompt. I will copy that prompt and come to Prompt Cowboy and paste that prompt here. You will get a very modified prompt developed by this Prompt Cowboy. So I am pasting now. So it will give me the modified prompt. Check it. See, it is giving me the wonderful modified prompt within a 10 seconds. And then you can copy this prompt and paste it there. You will get the wonderful answer. So this is called as a prompt generator, prompt enhancer. Your normal prompt, it is converting to the very professional prompt, and then you can copy this prompt. I am copying this prompt and I am going to the chat GPT again, and on the basis of that prompt I am pasting it, and it is giving me the answer. And it is giving me the answer. Check it. Check it. You will find an enhanced response here. So I request everyone, please use Prompt Cowboy whenever you want to write the prompting or other prompt enhancer. But don't just write the normal prompt. According to the normal prompt, it will give the normal answer. So use that Prompt Cowboy. Clear or not? So generative AI currently in the world is having this 4 spectrum. That is, first is prompt engineering, asking the right question in the beautiful way, giving the quality answer. Then when to use this RAG? RAG means one thing I wanted to ask you. Okay, concentrate on this diagram and give me the answer of that. Currently, you people are using ChatGPT, Gemini, Perplexity, Claude, that is a LLM. This LLM is totally trained on public data, open source data, which is publicly available, OSD, open source data. Here Wikipedia, website, and whatever the data publicly available, LLM has been trained on that. As a user, whenever you are asking any query, that is prompt engineering only. So you should know the rules and regulation of prompt engineering that I have shown to you. That is this one. Okay, this one. Where is that? This one. Framework of the prompt engineering. Whenever you are asking question to the LLM, which is trained on the open source data, and your question is related to open source world only, LLM will give the answer. It will give the answer. Now one question. You might be working in company or college or university here and there. So our company is having some confidential data, which is not publicly available. In the open source internet, it is not available. If I will ask the question to the LLM, to the data which is confidential and available in our company only, it is not publicly available. This is the data in our company. Okay. And if I will ask the question related to this data to the LLM, will LLM will give the answer? Tell me. With the generative AI will give you answer. If you will ask the question related to your confidential data,
No, it will not give the answer.
it will not give the answer. Correct? It will not give answer. That's what RAG come into picture. In the generative AI, there is one concept called as RAG, retrieval augmented generation. This retrieval augmented generation, what this person will do and this framework will do, whenever we will make architecture, RAG is the architecture. Right now, it is not a right time to go into deeper of that. So what RAG will do, whatever your company data is there, confidential data. So RAG is giving the opportunity to ask the question related to that company data. And in the RAG, we are using LLM only. So in the RAG application, ask the question to the confidential data, it will give the answer. But if you will ask any question related to open source world, who is Sachin Tendulkar, it will not give the answer if it is not in your data. So RAG is exactly opposite of this from the working culture. Normal LLM will give the answer because LLM is trained on open source internet data, and normal LLM will not give the answer related to confidential data of your company. Whereas the RAG will give the answer related to confidential data of the company, but not the open source world. This is a RAG. That's what there are so many projects we are building with the RAG application in the company. Advanced version of the RAG is fine tuning. We are just training the LLM on your company data and the tone of your company. If your company want to give the answer to the user in some specific way, tone, polite way, professional way, calm. So we are guiding the LLM accordingly and it will guide that. So that is fine tuning. And finally, AI agent and agentic AI. AI agent means to solve some task. And agentic AI means number of AI agent connected together to solve some complex task, one goal and so on. For example, where we are using the agentic AI, currently we have developed one product for the HR department. Okay. Traditionally, in the HR department, whenever the vacancy is there in the company, so HR department is releasing the job description in the market, JD. Then according to this job description, HR department is receiving number of thousands of resumes. Then HR department will shortlist the resume according to the JD, shortlist. Okay. Then to the shortlisted candidate, they will call some expert to take the interview. And after that, that interviewer will select and reject the candidate and so on. So to select one candidate, currently in the company, there is a 3 to 4 month process going on, which is very long process. Now the same process we did with the help of agentic AI. We have developed one AI agent. This AI agent, depending on the JD of the company or that role, if we are giving 10,000 CV to this AI agent and you are guiding, please shortlist top 100. So this AI agent will do within 2 minutes or within 1 minute, top 100 CV will be get shortlisted out of 10,000 CV, depending on the job description. Whatever the 100 CV is shortlisted now, this is AI agent 1. AI agent 2 will take the interview of 100 candidate. After that, AI agent 2 will select and reject the candidate. Select and reject. To the selected candidate, it will send a mail for the document verification, agent 3. And candidate will give the document and it will check that. For the rejected candidate, some reason to send a email. So here, majority complete process is agentic AI and different AI agent is working for the same. One AI agent for shortlisting resume, one AI agent for taking the interview, one AI agent for sending the email and so on. It is agentic AI. So depending on the task and the requirement in the company, we people are using this thing. Okay. So in the world of generative AI, how it is disrupting the society, majority cases in the world, every company is making conversational chatbot, either voice assistant or text based, with the help of RAG and fine tuning. But currently we are also making the AI agents for solving some repetitive tasks inside the company, and they are enhancing and optimizing the work productivity because of agentic AI. So the AI agent gone so much high nowadays that with the help of AI tools and AI agent, we are increasing the work productivity. For example, I don't know have you heard this or not. Have you heard the word called as vibe coding? Have you heard the word called as vibe coding? I am writing here. Let me tell you.
Yes.
How
Yes, sir.
many of you not heard about vibe coding? Or if you heard about vibe coding, it is well and good. I am writing the name here. Just a second. Just a moment, okay? A laptop got hanged. Just a moment. Now, vibe coding. Have you heard this word? One person heard the word. What about others? Heard about the name called as vibe coding? Everyone? Because the power of the world currently, you don't heard. Okay, let me guide you the vibe coding. Vibe coding means what? I will show you the magic now. Okay. Vibe coding means what? From any non-technical person, from the sales department, marketing department, or any from the engineering college, some professor from the no code background. Vibe coding means what? Writing the prompt for making the application, app, or any website also. Okay, website also. So vibe coding means write the prompt to the AI tool for making the app or applications, anything. So for that purpose, I will show you some demonstration. Very easy with the help of generative AI. So if you will go to the website called as lovable.dev, this is the name of that website, lovable.dev. Parallelly, there is one more website called as Replit. Okay, Replit AI. This one, Replit. Okay, this one. So let me show you the magic of lovable.dev. Okay, let me show you the magic of that. So I will paste the link in the chat window for lovable.dev. If you are joining from the laptop, please open this. I am sending the link in the chat window. Just a second. Sorry, I got disconnected. Let me share the screen again. Please confirm that my screen is visible. Please confirm.
Yes.
Yes, sir.
Yes. Yes.
I am pasting the link in the chat window. Please play around it today. Okay, I am pasting the link in the chat window. Lovable.dev. Now see the magic. Now I am writing here something in the lovable.dev. Check it. With the help of prompt engineering, create a digital calendar for 100 years. Give some Hindi name. I am writing here. Give some Hindi name. Give me the option for selecting day, or we can write down button. Give me the button for selecting day, month, and year. Make the app in blue color. Okay, now let's see the magic. You write on your own. I have given the link in the chat window. Open this and write down your idea there. What you want to develop website. Just write down, but in a very clear way. So let's see lovable.started. And I have asked them give some Hindi name. Now see, it has given the Hindi name Samay Chakra. See the wonderful capacity of lovable.dev now. Just wait for a moment. It will give the answer. It is creating the app now. See the magic. This process is called as vibe coding in the world. Generative AI vibe coding. And it will create wonderful, guys. Believe me, it is creating wonderful. So there are so many competitors of lovable.dev. One is Replit, one is mgx.dev, one is Emergent, and so on. So we are using this. Suppose if you are having some presentation to the client, you can make the application with the help of lovable.dev. You can just click here and enjoy the game now. See, and now parallel, this is a Replit. In the Replit, same thing, I will paste it here. Same thing. While lovable.dev is making that, I am pasting in the Replit. Check it. Now Replit started. This is the alternative competitor of lovable.dev. Competitor of that. Okay. Done. It's almost done. Now it will show the app to you. Check it. Now it will show. And wonderful. And meanwhile, here Replit. So it is building the entire app within 2 to 3 minutes, depending on your internet speed. Let's see lovable.dev. It will create in the blue color. Now check it, guys, in front of you, in the blue color. Your digital calendar is ready for 100 years. Check it. What is the today's date? 13th September. And today is Saturday. Check it. It is clearly mentioned Saturday. Check it. And suppose if we can change this 2025 to, for example, 2030. Guys, I have changed to 2030. Anyone please check it. What is the 13th September 2030? It is coming Friday or not? Check it. 13th September 2030 is Friday or not? Check it. Tell me.
Yes, sir, it's Friday.
It is Friday. See, working. And now suppose you want to publish this app to someone. So on the top right, I am clicking on publish. I will get one link here. I will copy that link. Okay. And I'm pasting my link in your chat window and open that. The same app will open, which will highlighting in my screen. And I'm pasting in the chat window. Check it. Please click on this link. You will get the same app which is in my screen. Samay Chakra. Check it. Opening. It might open the same. Check it. And tell me it is opening the same or not. And parallelly, this is a Replit. Replit is designing. Play around with this Replit. So this is the power of generative AI. Generative AI disrupting the world. Now, website developer, graphic designer is not required. And today is this position. Imagine after 1 year, oh my God, it will be the another planet. Just with the help of voice assistant, you can interact and make an app within 5 minutes. So this is a Replit going on. One more is there, that is called as Emergent. Emergent AI. This one, which is making the app within a minute. Emergent AI. Okay. So with the help of this process in the world of generative AI, we are disrupting the world a lot. Okay, this is the case. Emergent AI. This one, check it. So there are so many competitor. Okay, so many competitor here. Now we can develop anything in the world of generative AI by writing the prompt. Just by writing the prompt. So now current equation in the world is like this. It is compulsory for everyone to know prompt engineering now. Prompt engineering, rules and regulation, how to write down the wonderful prompt, plus domain knowledge. This is deadly equation. Domain. For example, if you are from the healthcare background, so you are the perfect person to write down the prompt in healthcare because you know the technicality of that healthcare part. If you are from the mechanical engineer, you are the perfect person to write down the prompt related to mechanical engineering because you are knowing the domain knowledge of mechanical engineering. So having the domain knowledge will enhance of prompt engineering writing process. You should have the domain knowledge, suppose mechanical engineering, and I am writing the prompt for mechanical domain. So with the help of rules and regulation of prompt engineering, I will write down one wonderful prompt and that I will give to AI. It will give the good answer. It will give the good answer. Okay. So in this way, you people are doing this all activity and this is coming under agentic AI. Okay. And AI agent is doing that. So now I am also writing to the emergent AI, this one. So it is going to create a app for me. And now this is Replit. So see, Replit has created Samay Darshak. Okay, Samay Darshak, but it is still working. Okay, it is still working, and then it will show the entire overview of that. And this is lovable.dev. I hope you are getting this. So guys, there are so many things in the world of generative AI to do. We are solving so many projects. We are making so many intelligent machines, intelligent products with the help of this rule. These 7 members, which I have shown in this slide. With the help of this 7 member, we are making so many disruptive applications for the society. Check it. This one. Okay. Any question till now? So
Okay, I
all,
have 2 questions.
please
I have
answer.
2 questions. Yeah.
Yes.
First thing that I have copy pasted this app, but it's not coming. Okay, in my laptop. So that is the first thing. And second question is that instead of using or developing RAG, suppose we have a small data set, and if we give that small data set to ChatGPT and then ask question, then
It
what is
was,
the difference?
difference is in the ChatGPT when you will ask the confidential data of your company, ChatGPT will take that data for the training. Okay, that's what data breach issue will happen. Whenever I am uploading
Yes.
anything here to the ChatGPT, so I am
Hmm.
giving my entire data to ChatGPT. So that's what so many organizations are not allowing you to ChatGPT internally. That's the challenge. Hence, we
Yes.
have to use RAG application to make the data privacy process in our application. Otherwise, the day when ChatGPT will already release the enterprise product, and if your organization and ChatGPT has signed the deal, then believe me, data scientist job will go away, data analyst job will go away. I will show you some magic here. Okay, let's check it. This is
No, no.
ChatGPT.
I am asking from performance point of view. If we develop RAG, and if we give data to the ChatGPT,
Yes,
which for which performance will be the better? Means obviously it will be
our
ChatGPT.
no. We are also using ChatGPT when we are developing the RAG. So what we are doing, we are checking the experimentation for our RAG. First, we will call the OpenAI model, that is ChatGPT. We will check the performance. Then we will call the Gemini model. We will check the performance. We will call the Llama. We will check the performance. We will call the Claude. Check the performance. When we are making the application, so we have to do comparative analysis of everyone. Blindly, we cannot apply ChatGPT because some process ChatGPT is good, some process Claude is good, and so on. So during making the product, because it is our duty to give the answer to the stakeholder, sir, I have made the RAG and I have done the experiment on top LLMs of the market. These are the top LLM. Performance of Gemini is good in our application. This is the performance of ChatGPT. This is the performance of the Claude. The entire presentation we are showing them. And then finally, we are releasing our product on the basis of model which is performing good.
Okay. Okay.
That is the
That's
case we have.
I want to show something, and thereafter I have some queries. Will
Yes,
you allow?
please. Please ask the question.
Yes, sir. Sir, I have made a web app in which my intention was to test MCQ questions to our students, and
Yeah.
while I was doing that, they are answering questions, and results are showing, but I can't save the results. That is the
What you can do? What you are not able to do? Your
save
voice save the data. You need to add a
save the data.
memory component in the RAG application. Okay, memory component you need to add it, and that whenever the question query it is asking, it is going to store in the vector DB. So that entire memory component need to add it, so that in future someone is going to log in. So our RAG is having the previous conversational knowledge in advance.
Okay,
So we have to add memory. Then it will be giving the answer of the previous conversation also, which ChatGPT is doing. ChatGPT is having the memory component. That's what ChatGPT is knowing by all previous prompting and the answers. Someone asked the question: is Gemini is using it while being used Gmail upon logging into our account? Yes, Gemini is using their pro level model for the entire email application. So, for example, here if you can see email on the top right, Gemini is here. Gemini. If I will ask Gemini, Gemini will ask me permission to reply the email and so on. So yes, nowadays your all email IDs and entire process is AI enabled automated systems. Whenever you
Sir,
will,
from last 4 or 5 days, we have learned about so many LLM models,
yes,
like you by using this prompt engineering and a lot. So
yeah,
from the all these, I have tried many of them. I have tried.
okay,
So for an example, I am creating a PPT using this Gamma.
okay,
So the problem is that the people whether I mean it might be possible I am not able to write the exact prompt I should write to get the desired content, and or maybe the problem with the free version. I mean it is necessary to take the pro version always
yes.
to create the.
If we are using the Gamma, obviously they are going to make a business. They are here for business only. So if we are making the
Mhm,
PPT from the Gamma, so in the free version they are only showing their
mhm.
capability. Hey, see, I am having the capability to solve this. If you take my pro version, you will get so many advanced features in that, and number of the slide of the PPT will increase. In the free version, only 10 slide we can make it in the Gamma.
10
But in
slide, yes,
the
yeah.
advanced version, we can go up to 60 slide with the most advanced features of that. Okay. So obviously they are here to make a business. And one more thing I would like to guide here. Always select the LLM depending on the task. Don't blindly choose the LLM. Every LLM is having its own ability. Prepare the cheat sheet. For example, I have prepared the cheat sheet for the open source LLM. There are so many open source LLM in the market. These are the list of Llama from Meta. Llama is also having different variant. Llama 7 billion, 13 billion, 30, 65. Each variant is having its own capacity to solve something. Similarly, Mistral LLM open source is having its own capacity. Falcon 7 billion, 40 billion, Bloom, and so on. This is a cheat sheet. When to use which LLM? This you should know. And companies are also releasing the guideline. Similarly, for the ChatGPT 5 also. Currently, in the ChatGPT 5, when you will use it, ChatGPT 5 is having 3 to 4 version. If you will click here, ChatGPT 5 Auto, it is telling that decide how long to think. Instant answer that way. That means the thing is which model should I use in the Gemini also, in the Llama also, in other LLM also. So you have to prepare the cheat sheet when to use which LLM. It will give the wonderful answers according to the task. If your task is suppose medical domain and the Llama is not trained on medical data and you are forcefully applying Llama on that, it will give the answer, it will hallucinate. So,
Okay,
so the
let us suppose, sir, I'm an academician. and from the computer science background itself. Uh, which version of this chat GPT I must use while I'm creating the content to teach in my class?
Right now, ChatGPT 4.0 and 5.2 only model available. Okay, so because they have depreciated the previous model. So if you want to teach something, so yeah, ChatGPT 5 you can use.
Okay, I'm using the same.
Yeah,
But
5
when
is,
I've tried the
I will
creating PPT using that,
no, no,
so
I will tell you.
I need to write the I mean I'm writing a prompt, so I need to give the instructions multiple times to it
Ah,
to
that's
get
what
the desired content.
because our prompt is weak. Weak prompt you are giving. You have to write down in
Okay,
the
okay,
prompt
okay.
all context, role, objective, action, output, sum, everything. Then you should give that. So that's what I have given you that prompt cowboy website name. The moment
Mm-hmm.
you write down the good prompt, then only it will give the answer. For example, okay, if I will ask the question, what is generative and explain me, it will give me the answer. Now I'm asking the subsequent prompt, what is generative and explain in 5 bullet point. It will give only 5 bullet point.
Right.
So what you want in the response, that context you need to set in the prompt, then there is no repetitive prompting.
Okay, sir. Thank you so much.
Thank you. So this is the case. So please prepare the cheat sheet for the using the LLM. Write LLM for the right task. You will get the good answers, and you can develop so many things. So this in this way we are developing the application. Obviously, within a 1.5 hour, it is a less time for us to build some application from scratch. But right now, in my session, I am showing you the capability of all generative AI, how it is disrupting the market, and going onwards, if we will not upgrade ourselves into the generative AI, so very dangerous. So that's what world is going in such a direction. You plus AI, two combination will be the deadly combination. Okay, so use AI for enhancing your work productivity, and whatever the things you are doing, it is going to do a wonderful job. It is going to do wonderful job, guys. Okay, so that's all from my side today. If you want to get connected with me, this is my LinkedIn. Okay, so you can connect with me anytime. I will be very happy to help you out. This is my LinkedIn. Okay, so I am guiding across the world for the same, and as I told you, mentor for the so many universities as well as colleges and the corporate, parallelly along with my main job. This is my parallel passion, you can say. So
So please share the LinkedIn link in the chat box.
just a second, I'm sharing that. I hope you have enjoyed the session. This is my LinkedIn link.
A
Okay,
lot. Thank you
and if
so
you
much.
want to get connected,
Commendable session it was.
I'm writing my contact detail as well. So I have written my contact detail in the chat window. Anytime you can connect with me, ping me in the WhatsApp before calling. Might be suppose if you are calling, I am in the session. Might be I will not receive that, but you can ping me. I can able to help you out. Don't worry. So that's all from my side. Thank you very much. It's a wonderful to interact with you, all of you. And within the less amount of time, it is our complex duty to guide you all the things in the simplest way. But I hope you have enjoyed my session.
Yeah, it was very nice session,
Uh,
sir. Thank you so much.
sir, I have one questions.
Yes,
Sir,
please.
ChatGPT taking the data from the open source, right?
Yes,
And you told that RAG is taking giving the private data. So
yes.
how the RAG is getting the private data from the companies?
RAG is getting the no, we are doing the type company is giving the project to us. So in the RAG pipeline, company is giving project to us. We are doing the type with the company. So obviously, company will give their data to us, and we are making in their either internal infrastructure or either cloud computing. So
That
company
data
will
is
give.
not available to the others, no, sir?
No, that will not available to others. Only you, if you are solving that business problem, it is between you and the company will sign the NDA with you. If any
Right.
data breach will occur, you will miss, company will gone.
So
Arpit sir,
can
we
we
are not
install?
able to connect with you on LinkedIn.
Because the reason is I already crossed the 30,000 subscriber, so
Oh,
you can able to follow me.
yeah, I have followed you. Thank you.
So after 30,000 connection, I cannot accept and send a request. That's the challenge in LinkedIn. So I am having 35,000 followers in that because of that reason.
Okay, sir. Can we install DeepSeek in our database, and can we learn the
Yes,
data with our company's
yes,
data?
yes. Llama you can install open source model, DeepSeek you can install, and then in your internal infrastructure only you can build a product. Possible.
Okay.
Open source model you can download it. Any other doubt? No more doubt. Okay, great. It's really nice to interact with you, all of you, and I feel you are a very interactive person. So thank you very much, and looking forward in future if our path suppose interact in future, and let me know any kind of help which I can do for you.
Okay, there are some questions in the chat box.
Yeah, so Gemini has enterprise mode version for company. Yes, Gemini has every LLM is having enterprise mode. You can purchase that. What are the benefit of this AI? Obviously, it is going to reduce your work time. If I will give you 500-page document and tomorrow is the meeting, as a human, I cannot read 500 page in one day. If I forcefully read also, I will not interpret properly. Same thing, I will give it to AI. Summarize this 500 page with a greater accuracy. Within 5 minutes, it will summarize that. Within 5 minutes. Okay, so many things.
No,
People
sir.
make,
No, sir. Sir, actually, I am telling what are the benefits of these AI companies?
okay, benefit of these AI companies.
Companies, because
they are
they are giving some solutions. We are use in a free of cost.
No, I will tell you that. Suppose Gamma, if you are using free of cost, okay. So you heard about Geo when Geo launched in the India, so 6 months they have given the free SIM to use. So they get habitual of using that, and after that they ask the paid subscription. Similarly, nowadays Gamma is AI, which is number one for making the PPT. Now we are habitual of making Gamma. Sometimes some work will come in your organization only where you need to make a 60-pager PPT. You are not having time, and the Gamma upgradation is 2000 rupees per month, for example. You will upgrade it and then you are going to take it. So this all AI tools are on subscription model. Subscription model means entire world can use it, and that's why subscription fees is very less. If you heard about ChatGPT Go, they have released for India, they have released ChatGPT Go product. Heard about that? It is only 400 rupees a month. So please don't use ChatGPT single individual version that of $20 a month. Don't use that now. Now use 400 rupees ChatGPT Go. So that's what this company is getting money from us only. So we are taking the subscription and they are earning a lot. So either it is a ChatGPT, either it is a Llama, either it is the other company. We are calling their API by paying something. We are using their subscription model by paying something, and they are going to make a business. You can also launch a product on the subscription basis. You will also going to make a business.
Okay, thank you, sir.
Thank you.
Okay,
Thanks.
so I think it is a very wonderful session. Normally in FDP, what we found that the sessions are mainly theoretical, but here we got a combination of theoretical and practical. Means practically what we can do, some of the glimpses you have shown to the participants. For that reason, participants got very interested about your session. So again, thank you very much for giving time from your precious time. What I means conceive that you are very busy. Still, you have given time to us. Thank you very much for that.
Thank you.
Okay. So with these words, I think I should conclude your session.
Thank you, sir.
And again, thank you to you.
Thank you, sir. Thank you very much.
Okay. And can you share your slides?
Sir, I will share the data related to slide. Slide is my IP, means company IP. So I will share the data in that. Okay.
Okay. Okay. Whatever you want to share that. I will share it with participants.
Okay. Sure. Sir,
if possible, then share the cheat sheets as well, if possible.
Sure. 100%.
Thank you so much.
Thank you.
Thank you. So It's a 4:59. It's 4:59. I think next speaker has not joined yet.
I have joined.
Okay. So yes, sir. So okay. So let's.
Unfortunately, my video is not working. I mentioned it. So
Okay. I was looking for your name in the among the participants. A lot of participants are there, so for that reason, I am not getting. Okay. So let's start the next session. 1 minute, sir. So let me introduce Dr. Paramartha Datta. Dr. Paramartha Datta, born in 1966, a BStat honors, MStat, MTech, Computer Science, all from Indian Statistical Institution, and a PhD engineering from Bengal Engineering and Science University, Shibpur. Presently, Indian Institute of Engineering, Science and Technology, is presently a professor in the Department of Computer and System Science, Visya Bharati University, India. Dr. Paramartha Datta is a fellow of IE India, fellow of IETE, fellow of IET UK, fellow of Royal Society of Arts UK, senior member of IEEE, senior member of ACM. He is the recipient of prestigious awards such as Distinguished Scientist in Computer Science and Engineering Award in 2018, conferred by Venus International Foundation, Excellence in Science and Technology Award 2018, conferred by the Indian Science Congress Association, Government of India, INSA Teacher Award in 2019, conferred by Indian National Science Academy, Government of India, Lifetime Achievement Award 2020, conferred by VDGOOD Technology Factory, Lifetime Achievement Award 2020, conferred by Science Father, Global Faculty Award 2020, conferred by AKS Education Awards, International Scientist Award 2020 award, conferred by International Research Award, England. Dr. Datta has 10 authored books, 24 edited books, and around 300 research articles published, accepted for publication in various esteemed journals, conference proceedings, book chapters in edited volumes, highly reputed international publishing house, and 17 patents granted or published. Dr. Datta has guided 17 PhD awarded scholars, apart from 8 who are registered scholars pursuing their PhD under his supervision. And for information to the participant, I am one of the PhD scholars of Dr. Paramartha Datta. He is my supervisor. So welcome to you, sir, and over to you for your talk.
thank you, Dr. Datta. So incidentally, myself, I am also Dr. Datta. So
yes.
thank you, Deepankar. Okay. So thank you for your nice introduction. And in fact, the moment I got your invitation, I readily accepted it. It's my privilege, as it has always been, to get some opportunity to discuss some of my, some of my findings. So it's a very nice opportunity, a nice platform to share or ventilate some of interesting issues, which I hope my audience will appreciate. And at the outset, I seek apology from all of you because my video is not working. And since, it's basically Murphy's Law. So it's not working. So I seek your apology. So only the voice channel or audio channel will be open from my end. So please bear with. So with this, without wasting any time, I think let me start with the kind permission from the chair. May I start, please?
Yes, definitely, sir. You can start.
I hope I am audible properly, right?
Yes, no problem.
Yes, sir.
Okay. Let me share then. So is it visible properly?
Yes.
Yes.
Sir.
Okay. So thank you once again for providing me the opportunity to ventilate some of my understandings or something that we have recently come across. Okay, so however, the talk of the topic of my talk in terms of title appears to be a bit, a bit scattered or flexible. I am not very sure about the composition of the audience as such, so that is the reason why I felt like keeping the topic of the talk rather, a generic one or a broader one, so that it can be appreciated by most. So today's topic is studies on non-dominated sorting in multi-objective optimization framework. Now, incidentally, multi-objective optimization or associated topic was also one of the content of Dipankar's thesis. So he also had his research investigation or study on this. So there is another coincidence. So let me get into the topic. Okay, so now I shall, in course of my discussion, I shall discuss what exactly non-dominated sorting means and what is multi-objective optimization, maybe in brief, and then I shall switch over to the basic content or core content of today's talk. Okay, so the roadmap for today's presentation looks like this. We shall be having a brief introduction, as may be useful for subsequent follow-up talk. Then comes why MOO stands for multi-objective optimization, such abbreviation. So why MOO and non-dominated sorting matter. State-of-the-art NDS algorithms. NDS stands for non-dominated sorting, once again abbreviation. Now there are several variants of non-dominated sorting, like FNDS, PNDS, and NLS. So we shall discuss them individually, a bit more details in course of time, and then some future ahead, or better to say some future scope. And last but not the least, it's time to wind up. So that is what the roadmap is for today. Occasionally, I shall investigate or inquire whether I am properly audible and my slides are visible, because I am using only one device, so it may be necessary. So once again, please bear with this occasional or hackneyed repetition like that. Okay. So coming to introduction. So so what is MOO or multi-objective optimization? I have reason to think that I believe that some part of the audience or major part of the audience as such may be well exposed by now, but still someone who is not that much exposed, for the sake of formality, let me introduce the concept of multi-objective optimization. And for those in the audience who are already exposed, may find it somewhat repetitive. Once again, please bear with others for this. Okay, so A multi-objective optimization problem is one that involves simultaneously optimizing 2 or 3 or even more conflicting objective functions. I owe explanation. Why exactly, what is important here? So first of all is the optimization simultaneous. Okay, so it means that an objective function means there are mathematical functions which need to be optimized. Now, number of optimizable objective functions is more than one. That is why it is multi. So it may be 2, 3, or even more. So theoretically speaking, there may be any number of objective functions that we may need to optimize together. So that is what is the basic framework of multi-objective optimization. Okay. Now, the question is, when we are thinking about optimizing a number of objective functions simultaneously, the problem is that in most of the real life scenarios, what we find is that one objective or optimization of one objective is basically influencing that of the other. So it means, suppose we have two objective functions. For the sake of simplicity, let us consider two objective functions, say f1 and f2. And when we try to optimize f1, we cannot do it without influencing f2, and vice versa. This is the typical scenario. That means it is mutually influencing situation that prevail. So that basically gives rise to so-called multi-objective, because of this, this so-called binding between the participating objectives together. Okay, so in other words, we may think that way, that one objective cannot be optimized without, or rather independently from another. So this is because all the objectives participating in the multi-objective optimization, multi-objective optimization requirement, they somehow are mutually influencing among themselves. So that is the essence. Okay, so it's not that multiple single objective optimizations. So multi-objective optimization, not exactly, or rather it is quite different from multiple parallel single objective optimizations. It's not so. So there lies exactly the challenge. To start with, let me, before going going into the formal definition, maybe one or two examples will give a better glimpse. So, for example, when we are dealing with say one objective, so it means that if we want to say maximize, so suppose a single objective is there. So, and this objective function generates two values, say one is 3 and say another is 5. And if we are in the process of maximizing the function, single objective function, then which one we should pick up? Definitely the option that is yielding the output 5, because 5 is greater than 3. So it means that there is some inherent comparison that takes place, whether consciously or unconsciously or subconsciously, doesn't matter, but basically some comparison mechanism is there, which leads us to infer or conclude that how to rank among different outcomes, that those are produced by the same objective functions in course of the optimization. Now, in respect of single objective optimization, life is easy, because you are going to compare on some values, numerical values. For the sake of simplicity, we assume the nature of functions involved, they generate numerical values. Situation will be difficult if we have to deal with non-numerical scenarios. I am not going into that part because it is somewhat tricky. Okay, so it's not exactly coming within the scope of the present discussion. So coming back to the thread which I left. So when it is single objective, comparison is always easy, because basically we are in course of that comparison, we have to compare two scalar quantities or scalar numerical values. So deciding as to which one is bigger or which one is less is always easy and straightforward. Now the scenario becomes drastically different the moment the optimization procedure involves more than one objective, or maybe two objectives. Even to start with, for the sake of simplicity, two objectives. So there will be results like in tuple form. Say, for example, with first component representing the outcome of the first function, first objective function. Second one is the result of the second objective function. So it means that your typical functional values will look like or appear in tuple forms like 2, 3, 6, 4, something like that. Even if we consider numerical values only. So it's a two-dimensional or planar situation, or on this plane there are several points which are basically your basically your outcomes corresponding to two objectives operating together. Now here comes the question: the comparison which we were comfortable in doing on single objective case earlier, we cannot enjoy that much of freedom or liberty like that in that simple way here. Because, for example, if it is asked, out of two such elements, two such tuples, say 2, 3 and 3, 2, which one is dominating the other? I mean, which one is larger and which one is smaller? So it's very difficult, because in fact it's not exactly possible either, technically speaking, because with respect to the first component, your answer is one. With respect to the second component, your answer is the other. So there is component-wise sort of conflict that appears. So this possibility is very much a reality in respect of whenever you go for multi-objective optimization involving more than one objective function for your study. So this is the background. Now let us try to formalize the definition. So when it is multi-objective optimization, it's basically minimization or maximization. Optimization may be minimization type or maximization type. So here typically say this is a generalized mathematical definition. So there may be m many objective components. So f1, f2, fm. So basically it's a vector of objective function values, m many. So it's a m-dimensional objective vector that way. And subject to, there may be various inequality constraints, there may be equality constraints. So I mean, in generalized representation, a multi-objective optimization comprises more than one objective functions to be optimized simultaneously. Individually, each and every individual component may need to be maximized or minimized, or maybe combination, subject to certain equality constraints represented in terms of G in this context, and some equality constraints represented as H. So the number of constraints, inequality or equality, they may be theoretically quite any number of constraints may be there. Okay, so this is what exactly is the formal mathematical definition. Now there is another variant or maybe extension of multi-objective optimization known as many objective optimization, which is to distinguish from MOO. It is represented as MAOO. So this essentially higher dimensional multi-objective optimization, technically speaking, which consists of objective functions more than 3, I mean greater than equal to 3 basically. So it means that when we are to deal with less number of objectives under our consideration, then it is multi-objective optimization. But the moment it becomes our requirement to optimize quite a good number or formidable number of objectives together, then it comes under the scope of many objective optimization. So that is it. And the right hand side gives a figurative representation where it's just to provide an example where we are dealing with, dealing with, say regarding a railway ticket booking. For example, there are options in terms of travel time, which we definitely try to minimize. In order to reach a particular destination, we try to get hold of a train that is very short or as short as possible in terms of travel time. So travel time may be considered as one objective here, which is of minimization type, represented along horizontal axis in the graph, and another may be your ticket cost, so which is represented along the vertical axis, where typically the ticket cost we should look, or we should try to minimize it also, because nobody thinks of shelling out extra penny for procuring a ticket, so it should be as minimum as possible. So if we think in terms of these two objectives together, with travel time on one side and ticket cost with the other, the question is, and both we try to minimize together, the question is, are these two independent of one another? The answer is no, because it's common that if we want to optimize or if we want to minimize travel time, we should remain prepared to shell out some extra money for that. So the cost is somehow expected to go up, and vice versa. In order, if we want to curtail the ticket cost, then we have to remain prepared for extra travel time corresponding to that particular train. So there is sort of a conflicting sort of conflict existing between these two objectives, with one is contradicting another. So minimization of both simultaneously, that is why it's difficult to achieve. And moreover, out of these two, if we want to minimize one, we cannot, it's not independent of the other. So it influences the other. That is where exactly it is not independent single objective, two single objective optimizations. It's rather bi-objective or two objective situation that we have to deal with in this context. So I hope that's this basic background is made clear, possibly properly. So am I audible, by the way? Properly? Am I audible?
Yes, yes.
Okay.
Yes.
Thank you.
Yes, sir.
So with this, let me proceed. Now, in course of or in respect of multi-objective optimization, there are two spaces involved in the entire framework. One is what is known as the decision space, the other is the objective space. So, for example, typically when we think of a function, say f, so f is a function which involves certain input variables. So for example, if y equal to fx is the function description, so that here f is the function, x is your input variable, and y is your output or outcome of the function. That means when f is applied on a specific value of x, it yields y. So we know it. So from engineering perspective, we may think that x is your input, f is your processing block, and y is your output. We can think that way if we find it convenient. It's basically the same thing representing in different ways. So it doesn't matter. Now the question is, decision space is comprising, it's basically containing all the elements. Those may come as input of the function. So it means that it may be multidimensional. So in case of my function f involves more than one input variable, then it's the dimension of the decision space grows. So for example, if z equal to fxy is my function, then since there are two inputs x and y, corresponding to the function f, then my decision space is a two-dimensional decision space. So generally speaking, it may be say k-dimensional, where typically the description would look like f of x1, x2, xk, right? So so decision space is basically those valid input points on which a function may be applied. Okay, so this is decision space, I hope. So decision space involves elements which are essentially the variable points on which functions may be applied. Coming to objective space, this is the other side of the coin, where objective space here also in multi-objective scenario may consist of multiple dimensions. For the sake of simplicity, here we are considering it's a two-objective or bi-objective case involving two objective functions, so f1 and f2. So here what happens is that, so given f1, the first objective, so basically f1 is applied on all the valid points of the decision space. So there will be corresponding f1 values. Similarly, which are basically the first component of my objective tuple, if we think that way. So similarly, the different values of f2 are generated by applying f2 on different decision space elements. So accordingly, for each and every individual decision space element, there will be a single objective space element, f1 of say x1, x2, xk, and f2 of x1, x2, xk. So this f1 and f2 values, if we represent it that way, it is basically giving rise to your objective space. So what is the difference then? To sum up, decision space is containing elements of the variables. On the contrary, the objective space comprises the functional values once applied on those individual decision space elements. So needless to say that objective space is derived, or it's a derived one. It's derived from the original decision space, or in other words, objective space is induced from in that way, functional induction, multifunctional induction, so to say, to be more specific, derived from the decision space elements. So maybe interpreted in a cause-effect type of relationship. Basically, decision space elements are your cause, and objective space elements are your effect. So we can think that way or perceive that way also, if it is convenient. So this is how decision space and the concept of objective space, these are clarified. So now basically when we are, here comes the question. There are a few questions which I feel very much inclined to present before you, the august audience. Okay, so we talked about, please note, we talked about f1 applied on x1, x2. In this particular, let us concentrate on this particular, representation, graphical representation. So here, decision space is two-dimensional, objective space is also two-dimensional. So decision variables are x1 and x2. Objective functions are f1 and f2. Now, it means that f1 is a function which is a two-dimensional, which operates on two-dimensional elements. That means f1 of x1, x2. Similarly, f2 is also acting on x1, x2 values. That means f2 of x1 and x2. Now, here is a implicit assumption that both these objectives, participating objectives f1 and f2, they are acting on the same decision space, right? So the decision space is common, on which both f1 and f2 are working. If we want to generalize it, it means that if it is a multi-objective or objective more than, a many number of objectives are involved, the implicit assumption is that all the participating objectives, they are working on the same common decision space, right? Now here is a here is the difficulty. Okay, so present literature is in this particular context, they are very much equipped with respect to this assumption. Now let us think of, it may so happen, suppose instead of two-dimensional decision space, let us consider that my decision space is a three-dimensional decision space, whereas my objective space is two-dimensional, F1 and F2. Decision space is comprising X1, X2, X3 elements, right? Now it may so happen that F1 is a function of X1 and X2. It is independent of X3, it may so happen. And think that F2 is involving or operating on decision variables X2 and X3. Okay, it may so happen, right? So it means that in that case, the decision space becomes objective function specific rather than a generic or a common one as it was before. Now, the entire framework becomes, you need to redefine or restructure the entire multi-objective optimization framework in this particular type of situation. Now, the simplest case is, let us concentrate on this. Suppose in this scenario, say F1 is dependent on, or F1 involves X1 as its input variable. It is no way bothered with X2. Let us assume for the sake of simplicity. F2 is involving X2 alone, no X1. So F1 of X1, basically what happens? F1 of X1 and F2 of X2. If this is so, incidentally, it means that essentially this bi-objective optimization is no more bi-objective. It becomes two single objective optimizations working independently, because neither F1 is in a position to influence F2 nor F2 is in a position to influence F1. So they may run concurrently or parallelly for execution or for achieving their respective optimizations. Okay. Now, so long, it means what? It means that when one objective is involving some decision variables, which is non-overlapping with that of the other. Okay, so it means that basically decomposition of the decision space in a different way. You can think that way. If that is possible, then you can think of parallelizing your multi-objective optimization among those non-overlapping decision space defined or space directed or space decision space controlled objectives. So that is possible, but generally it may not be so, as I was saying. So F1, say for example, F1, coming back to the original example, so say F1 is dependent on X1, X2, and say F2 is dependent on X2 and X3. So can we dissociate these two functions, F1 and F2? Answer is no, because somehow through X2 they are involved with one another. They are intertwined with one another. So one cannot be segregated from the other. So that is the difficult part. I hope I could make it understandable to you. Okay, so this is one part. So it means that when so long your decision space is a common one, your formulation is straightforward. In fact, most of the literature they work on that framework. But when your decision space becomes decomposable in that way, it may not be non-overlapping all the time. Then we need some separate mathematical framework altogether to carry on further. Yeah. So this is one sort of open problem or problem where we can think or we can divert our effort. So this is one potential area. Okay. So with this background, now the question of what next comes is Pareto dominance and non-dominance. So dominance and non-dominance, these two are complementary type of situation. But please note that the question of dominance is very much very much straightforward in one-dimensional case, the example which I have already provided earlier. But when it comes to the question of 2 dimension or more than 1 dimension, that means 2 dimensions or more than 2 dimensions involved, then say 3, 2 and 2, 3, out of these two, which one is dominating the other? So it's very difficult to decide. Okay, so accordingly, for higher dimension case, that means 2 or more than 2 dimensional case, here it means that the domination has to be specified accordingly. So a solution A dominates B, mathematically speaking, a solution A dominates B if A is no worse than B in all objectives. So and now the question worse is very much need to be clarified. So if we go for minimization, then worse means that no worse than means greater than equal to, or the situation will be reversed in case the nature of optimization gets reversed. So depending upon which type of optimization we have to carry out, your notion of worse or better will be determined accordingly. So we hope it is understood. A solution A dominates B if A is no worse than B in all objectives, that means with respect to all the objectives that involves the multi-objective optimization process, and A is strictly better in at least one objective. So it's not that less than equal to or greater than equal to type holding good with respect to all objectives. In respect of the second condition, demands that in at least in one objective, it should be strictly greater than or strictly less than prevalent. Okay, so that otherwise the indeterminacy situation cannot be resolved. Okay, so the second condition is it may appear a bit strict, but it has to be there in order to decide the emphatically about the domination of one over the other. Okay, a solution is non-dominated. There's a other scenario. If no other solution dominates it, okay, think of a specific solution. It's non-dominated if no other solution dominates it. The set of all non-dominated solutions forms the Pareto optimal set in decision space. Now, in one thing we must be very careful about that, since there are two spaces involved in the entire process, with one is the decision space, with the other is the objective space. The question of domination, non-domination, as the case may be, we need to be very specific which type of space we are dealing with in which context. For example, a solution in this particular context, a solution is non-dominated if no other solution dominates it. Number one, domination we have already defined earlier, previously. Then the set of all non-dominated solution forms the Pareto optimal set in decision space. So the space is defined, it is in decision space. When it comes to their mapping, that means after application of the function on these decision space elements, their mapping forms the Pareto front in objective space. Now, this is important. So accordingly, there are two types of Pareto scenario. One is known as Pareto front, the other one is Pareto optimal set. So these two are somewhat technically different. Pareto optimal set refers to certain elements within the decision space, whereas Pareto front refers to certain elements in objective space. So there must not be any confusion in any subsequent discussion that should come. Okay, so it is clarified. In this example, A, B, for example, let us refer to the right-hand side figure. So A, B, and C. So 3 points. They are non-dominated, whereas D is dominated. So for example, is A, B, C, D, all these points are in respect to this travel time versus travel cost, basically minimization, both minimization type. This means that out of these two, A, B, C, and D, definitely D is unacceptable, because in terms of travel time as well as in terms of cost, both are, in terms of both, it is not going to, going to be acceptable, right? So that way D remains unacceptable. Rather, in other words, D is dominated by all A, B, and C. So D is unacceptable. It is kept behind. Out of the three A, B, and C. Now see, A, B, and C, they are non-dominated because, well, if you compare between A and B, A is having higher cost but lower travel time, whereas B is having lower cost but higher travel time. So that way it conflicts, right? So you cannot say that A is better than or dominating B or the other way around. Okay. Similarly, if we compare B and C, same is the scenario. So A, B, C, these are basically points where you cannot decide as to one is dominating the other or being dominated by the other. Okay, so they are non-dominated. Pairwise non-dominated, or they belong to the non-dominated set that way. So please note that when it is a question of dominance or non-dominance, the space that is involved here, this is the objective space. So accordingly, A, B, C, or D in this example, they are all objective space points, not decision space. So one must be very clear about it. Okay. Am I audible properly, Vaidi bhai? Okay.
Yes, sir. Yes, sir.
So let me proceed then. Now, with this background, the question why MO and non-dominated sorting matter. So, although it is somehow by this time a bit clear, but even then. So the importance of MO, it captures real world complexity. In fact, as I have mentioned, and also our common experience suggests that in real life situation, most of our decision making problems, they are very much multi-objective decision making. They involve multiple objectives together. So one is better in this way, but worse in the other. So we have to make a decision, sort of making some trade-off between conflicting requirements. So this trading off between conflicting requirements is essentially coming out because of the underlying multi-objective requirement to be fulfilled. So it captures real world complexity in that way. Helps decision makers understand trade-offs, as I just mentioned sentence back. Then provides a menu of optimal choices instead of a single answer. This is important. So, for example, in single dimensional scenario, 5 is greater than 3. So going back to the original example that I provided. So if I have to choose out of 5 and 3, and my intention is to go for maximization, I shall definitely choose 5. So there is no problem at all. But going back to this particular situation, if we have to choose between A, B, and C, which one we should choose? So it depends upon it. Becomes basically it becomes matter of subjective choice. Okay, so I may opt for B, someone else may opt for A, someone else may opt for C, and nobody can question, or nobody's choice can be questioned by that of the other, because as such A, B, and C, all these are non-dominated. So long we are all my points are Pareto front, or maybe Pareto front elements. That means nobody is going to dominate the other within that set. Then Pareto optimal set, to be more specific. Then there may be more than one number of solutions, number one, and any solution is acceptable because it is neither dominated by another, and nor it is in fact neither is being dominated by the other. So long my accepted solution is not dominated by that of another, I am safe always. I can go for A, B, or C, any damn one, because I know for sure that I mean, I cannot be beaten in terms of the performance by anyone else. Okay, so the one that I have chosen is definitely not going to be dominated by anyone else. So that way I am safe. Okay. So this is the question. So the number of answer may not be single always. In fact, what is provided or what is obtained as a result is essentially a Pareto optimal set comprising so many elements, with each and every element is mutually non-dominant. Nobody is going to dominate over another within that set, and it is safe. So that way, any element within that Pareto optimal set is going to serve your purpose. So your options are quite a number rather than a single one. Coming to applications, there may be several applications. It's just a very limited options that which are figuring here. That is, application of a multi-objective optimization is all for heading that way. Yeah, so excuse me. Now, when it is a transportation, we have just seen, say, time versus cost. That is typically a transportation application. There may be healthcare application where, say, effectiveness of a drug versus its side effects may be considered. So, when prescribing a drug, there may be two aspects. One is effectiveness, and the other is the side effect. So, side effect, the objective should be to minimize side effect and to maximize effectiveness. So that is it. So it's an example in healthcare. For example, the right hand side is it's a finance. For example, risk versus return. So very much applicable in share market decision making, where I want to maximize return, but at the same time minimize risk. Okay, so it's by objective in that respect. Now, in all these cases, may it be transportation, healthcare, or finance, which have been depicted here in terms of graphical representations, the respective objectives, they are not dissociated, operationally dissociated from the other. That is the reason why multi-objective optimization is very much a real-life challenging proposition, right? So it is so. Now coming to non-dominated sorting, or NDS in short. So non-dominated sorting, which is very much principally very much framed in terms of the notion of dominance or non-dominance, as the case may be. So, and very much useful in deciding determining the Pareto optimal set, which exactly is our cherished goal in respect of multi-objective optimization requirement. So NDS, abbreviation of non-dominated sorting, is a procedure used in multi or many objective optimization to classify and rank solutions based on Pareto dominance, right? So its basic purpose is to go for proper classification and ranking solutions based on Pareto dominance. We shall further see a bit later. Generally, it works by identifying all non-dominated solutions. Non-dominated solutions means those solutions which are not dominated by any other. Okay, so let us consider technically any element in a Pareto optimal set. A Pareto optimal set we have already defined. Anyone in the Pareto optimal set. Hello? Any problem? May I proceed, please?
Yeah. Thank you, sir.
So, any element within the Pareto optimal set satisfies the characteristic that it is not dominated by anything. Okay, so that is why it is safe. So that is why non-dominated solution or getting hold of non-dominated solution is one of the primary challenge in this context. So identifying all non-dominated solutions, that means not dominated by anyone. These solutions, when collected, they form the front one. That means the best trade-offs. In other words, this is also alternatively referred to as Pareto optimal set in objective space, of course. Now, next what we do is basically we set aside those who have already been identified forming the front one or Pareto optimal set. Setting them aside, we concentrate on the rest of the elements. Once again, we carry on the same argument there. So accordingly, we come out with the next level of solutions who are going to form front two. So if front one elements are set aside, then front two elements form the best solution. Otherwise, just below second category or second grade solutions, just below front one solutions. So we proceed this way. So we repeat the process until all solutions are exhausted, sorted. Getting inside at least one front. Okay, so when each and every element within the set, they get into their appropriate front, then this particular sorting process is complete, which is basically non-dominated sorting. Okay. So now the significance, next comes is the significance of non-dominated sorting. In multi-objective optimization, there is usually no single best solution mentioned repeatedly. Okay, so naturally the question of mutually non-dominant, within front non-dominance and between front domination, one front over the other, this type of decision making or this type of finding becomes important. This for the sake of ranking individual solutions, maybe within front or distribution across fronts, in whichever way we want to interpret it. Next, we need a systematic way to rank solutions without aggregating objectives into one. So now NDS exactly provides a hierarchical classification that is important. This induces a hierarchical classification with front one, the way it has been explained, is the best one, then front two, so on and so forth. Now, there are algorithms. This achieves this goal of this type of requirement. So, for example, if we go for evolutionary algorithms of evolutionary nature, then it is NSJ2 or NSJ3, very well known, very reputed algorithms, very popular. So they are there. Okay, now basically when this NDS they are formulated or they are found out, graphically this will yield structures like this. So for example, objective 1 and objective 2, this right hand side graph I am talking about. So objective 1 and objective 2, where both are minimization, we try to minimize both. Then there will be collection of elements within fronts depicted using different colors. Okay, so with green one is the front one, that means the best one. Next is blue one, which is the front two, next level. Next level is front 3 in yellow, and then in red this is front 4. So out of so many options, so red points or red mark points residing on red curve, they are faring badly among so many, and green one, they are performing the best. In fact, this green one, or the front one, is essentially, we can think that it is our Pareto optimal set. All right. So am I properly audible and my slides are visible?
Yes, yes. No.
Okay.
Yes, sir, you are audible.
Yes, sir. Yes.
Okay. Now the question is, this is the time. Now, when we are talking about non-dominated sorting, yet another point I want to draw your kind attention to. I hope that you are with me. So whatever we have discussed so far, please note that the data set on which this non-dominated sorting is applied, that means my decision space elements, originally decision space elements, these decision space elements on which we start carrying out our process, whatever algorithm it may be, non-dominated sorting algorithm. Now these elements, which is alternatively is my data set, so to say, this data set is static in nature. Static means that this data set, once we start our operation on that data set, it doesn't change. Okay, so once the processing of the algorithm starts, that means any algorithm on non-dominated sorting that works, once it starts working, question of inclusion or arrival of any new data item in my decision space is not allowed. Okay, so this is some sort of static non-dominated sorting mechanism. The scenario will change, definitely. I hope you understand. If in addition to this, we allow new data items means decision space elements. If we allow decision space elements to arrive in course of our optimization process, okay, or non-dominated sorting process. So the entire scenario becomes, in that case, online. So nature of data becomes stream data rather than static data. So the entire non-dominated sorting, here's the difficult proposition now. Life is not that easy anymore, because every time you are in a changing scenario, dynamically changing, evolving scenario. So naturally, whatever decision you make with respect to your elements right now, the next moment you are not safe, you are not secure, because by this time some other element might have arrived and entirely upsetting all the calculations and results that you obtained so far. That is possible. So naturally, handling this online or online non-dominated sorting or online sorting, or maybe on stream data especially, is otherwise a very challenging one. So this is yet another area where very limited reportings have been noticed as yet. Definitely we shall discuss a few for the present. So let us proceed. Now, before going into that, a very brief sort of discussion on state of the art NDS algorithm. So there are various non-dominated sorting algorithms of different types, of which each and every one is having some pros and cons as well as. So some very important, well reported, very popular, which we are going to represent now. So this is definitely not exhaustive, but a few which are quite popular and which are quite frequently used and referred to and cited in literature. Okay, so these are these. So this particular chart provides you the information that what is the algorithm, in which year it was reported, complexity, time complexity, best case, worst case, then corresponding case complexity, and the one that I have pointed out just few moments back, whether it is online compliant or not. That means it is capable of handling online stream data or not. Okay, so this is what it is reported, and there are some specific reports corresponding to each and every individual state-of-the-art technique. Now, what I mean, apart from other, what I want to draw your kind attention to is the online column with red cross marks everywhere except a few. For example, in 2016, there were two reportings, AENS and ENLU algorithms, which are online compliant, number one. And then there is another reporting, NLS, in 2025, which is yet another, which is online compliant. So naturally, this is a nice challenge. I invite participants and others to think in this direction also. It's a otherwise very nascent and open field that way. Okay, so I am not going to detail out further. I mean, by going individual contribution, this is just a piece of information which is very well known and well referred, well cited. So you can consult literature and it may be available. So these are there. Okay. Now, these are basically your NDS category algorithms or NDS algorithms of different kind, which we are going to discuss. Sorry. So which we are going to discuss now. So we shall take up one by one. First FNDS, then PNDS, and then NLS. Okay. Sorry. Now, FNDS is basically the most primitive one, which is fast non-dominated sorting used in NSJ2 and NSJ3, the one which was a starting point, so to say, but is very popular and very natural. The reason of its popularity is because of its natural way of thinking. So, common human, perception, the way it goes is very much similar to that. So in fact, that is what we have already explained. So for each solution P, solution stores set, SP is the set, solutions dominated by P. So consider a specific P, then with respect to this choice P, collect those solutions which are dominated by P. Okay. And there is another count NP is maintained where the number of solutions dominating P, that is also kept track of. Now, with solutions NP equal to 0, this is front one elements. That means for front one, this must satisfy this domination property corresponding to P. So for the step number 3 is the important one. For each P in front one, there is a repetitive loop. So there is a loop inside. So there are two loops working. Each time one more solution is obtained in SP, NQ value is decremented, and otherwise, and moreover, this Q is assigned to the next front. That means front 2. So that way it is repeated until all the solutions are exhausted. So as a result, what takes place is that basically all the solutions are decomposed or classified hierarchically in terms of certain number of fronts, with each and every front containing mutually non-dominated solutions within themselves. So as a result of application of first non-dominated sorting or FNDS, this is how it works. Now, since there are two loops with outer and inner performing, naturally, when it comes to the question of complexity, time complexity, naturally it's quadratic, has to be, okay? Because I mean there is an outer loop and inner loop working together. In fact, for example, this is a setup. This is the old problem. It's a time versus cost, both minimization problem. So, for example, suppose there are a few solutions A, B, C, D, E, F. So it's like this. So, in respect of time and cost, which are provided, and so A, B, C, D, E, F. Their information. They're very much available to us. Next comes dominance check. So naturally, in respect of time and cost, this means two objectives. We can infer that A dominates D, B dominates D. So these are, different dominance and dominated, non-dominance type of relations among these different A, B, C, D, E, F solutions. So as a result, what we get, basically this is, I'm not going to explain it because possibly I'm running short of time. There are another two algorithms as well, newer algorithms. But basically what happens is that the way this algorithm has been stated, if you proceed according to that, you get your SP and NP accordingly. So these are individual steps are demonstrated here. And eventually, after all intermediate steps, eventually you get into your points, solution points, objective solution points like this, with some marked green and some marked red. So accordingly, A, B, C, E, these are green marked, and D and F, they are red marked. So accordingly, there is a two-front decomposition of all 6 elements, right? And naturally, which one is better? Because it's a cost time consideration where we intend or we try to minimize both. So naturally, our green one, that means A, B, C, and D, they are more acceptable, more preferable compared to the red mark, that means D and F solutions. So naturally, there are two fronts. What is my front one or Pareto optimal set? This is A, B, C, and D, and what is my front two? This is D and F. Okay, so this is a simple case where the decomposition, after the decomposition, there are two fronts generated. But in a real life situation, there may be multiple fronts where this is possible that many fronts are generated, hierarchical fronts are generated. It is possible. So it entirely depends upon the data on which we are carrying out our optimization process. Okay. So this is the way FNDS works. So next is what is PNDS? The next in the agenda, which is pivot-based non-dominated sorting. The question of pivot is essentially, I'm not sure whether it is properly visible because from font size are very simple. We tried to accommodate everything within this slide. So essentially, these are these highlighted points are your pivots. Pivots means basically identifying those elements with respect to a specific objective, which is the best one. So this best one plays the role of a pivot with respect to that objective. So essentially, we identify the pivot points. This is step number 1. Place all the pivot points in front ith front basically. Compare all other elements with front I elements. If elements are mutually non-dominant with all front I elements, then place it in front I, else keep it in left buffer. So if there is even a single, single non-conformity, then it is kept in the left buffer. And it is continued for all other elements by incrementing front index by 1 until left becomes empty. So what happens is that through this process, basically, based on the pivot points, that means utilizing the pivot information, we are trying to rank different elements across different fronts. That is the basic spirit, right? And this algorithm takes care of that. Now, it's a deterministic algorithm like FNDS. There is no scope of non-determinism at all. And in fact, this gives you, this is bound to give you proper solution. So that way its correctness, there is no question about its correctness and completeness. So that is already established. In fact, this is one of our works which has already been reported. Now, just to give one small example. For example, this is one. So there are 10 points from point 1, 2, 3 up to 10 with objective 1 and objective 2. Both are of maximization type. That means higher value is always preferred. So which is the pivot 1 corresponding to the first objective? 692, because in the objective 1 column, 692 is the highest value. And we are going for maximization. Had it been minimization, then we would have opted for 78. Okay, so I hope it is understood. Same is the story with the next column, that means objective 2 column, which is also undergoing maximization. So here 1006 is the best one. So naturally, accordingly, this 692 and 1006, these are marked with bold facet because they are forming the front one that way. Okay. Now this is interesting that this is particularly a very very rare combination where both the pivots, both pivots of both the components, they are within one particular one particular solution. Okay? So it may not be so. It may so happen that first component wise one pivot is represented, while in respect of the other component some other solution is providing you the pivot element. That is possible. So but in this particular case it is a simple case. So this is your front one. So what is your front one element or Pareto optimal set element in this context? It is purely 692 and 1006. Okay. Now next comes the question, is there any other element, that means elements starting from 2 to up to 10, which can compete this particular element in the front one? Answer is no, because all other elements are dominated by point 1, the solution number 1. So naturally, any other element starting from 2 up to 10, they are not going to take a berth or get a berth in front one. So eventually, front one will be a single element front one where only this 692.1006 will be the singular, singular solution. So this is a case where this particular solution 692.1006 as the Pareto optimal, element in the Pareto optimal solution set is the unquestioned leader, because it is not, first of all, it dominates all other, number one, and nobody maintains non-dominance with itself. That is also true. So that way it is unique. Okay, so the number of optimum, how many is the number of optimum? It's a single optimum scenario. Am I audible?
Yes.
Okay. So coming to, after front one is settled, coming to front two. So please note that 692 and 1006, they are now set aside. So they have been painted through. So there are no more, once this particular 692.1006 has captured front one, story is over there. Okay. Now coming to the issue of considering the next level elements, which are front 2. So say here in front 2, 404, this is the first component pivot, whereas 609 is the second component figure. Now accordingly we pick up these two. Okay. So accordingly, solution 7 and solution 9, they are coming in front 2. Now please note that between solution 9 and solution 7, they are non-dominating with one another. So with respect to one component, one may dominate the other, but with respect to other component, it is dominated by the other. So clearly in respect of all objectives, one is dominating the other, it is not the case. So naturally, they maintain mutual non-dominance relation between themselves. Okay? So accordingly, 7 and 9, these two are going to be included in front 2. Now please note that apart from 7 and 9, is there any other element which can be included in front 2? Answer is no. Answer is no. Okay, so this is my front 2. So front 2 is identified. Once again, once front 2 is identified, we just scratch them. So solutions 7 and solution 9, they are set behind, right? So 3 elements or 3 solutions are gone out of 10. So 7 are still present. So next comes the front 3. The same story is repeated. So this way it goes. So after, we are not going to exhibit each and every individual iteration, but at the end, when the empty list is encountered, that means there is no residual element, all the elements are exhausted, you stop, and your decomposed fronts look like this. So the front 1 contains element 1, front 2 contains element 7 and 9, front 3 contains element 10, so on and so forth. It's like this. So how many fronts are there after this decomposition? 7 many fronts. So the entire 10 points or 10 elements, objective elements, they are decomposed into 7 such hierarchical fronts. So this is essentially your PNDS, pivot-based non-dominated sorting. Excuse me. So this is, it has been proved that it is complete and correct. In course of my presentation also I have mentioned that. Question is it offline? It is offline. Incidentally, if the question comes, can it be arranged for online mechanism? Unfortunately, no, because your pivot may get upset. So you choose your pivot based on your available data set at any stage. So if I allow some more data arrival, then the original pivot may get disturbed. So accordingly, the entire computation goes into waste. So what is the moral of the story? So PNDS as such, pivot-based non-dominated sorting, is it offline? First of all, it is offline complete. I mean, it very much works on static data in a very complete and correct manner, no doubt about it. But is it online compliant? Answer is big no. Complexity-wise, it is quadratic because every time once one front is fixed, the next front there will be repetition. Now, all these, I mean, this particular algorithm has been tested on different benchmark data sets. So these are benchmark data sets available in public domain. So accordingly, they are validated, right? So okay, so this is the corresponding publication. This is one of our publications. It's a conference called PREMI. You must be aware. The last year PREMI that was accepted. Okay, so this is PNDS, which I have explained now, discussed now. Then there is another one, which is the next one, nested link structure. Now, even at this time, after this reporting of PNDS or pivot-based non-dominated sorting, we had in mind, our team was there in mind that, well, whatever we could achieve, we could not achieve, or we fell short of anything more, better than quadratic, number one. So we could not do in terms of complexity scenario, we could not beat FNDS, number one. And number two, it's still offline. So in that way, it's yet another approach, but no, it is going to serve better in terms of performance. It's a novel one, no doubt about it, but still. So we were haunted by this, by this challenge that how to make it compliant. So here comes the next scenario, which is nested link structure, or NLS. So NLS is basically, it's very much interesting in the sense that it is a dynamic linked list structure or dynamic list structure that works. So the basic contribution here is more a matter of data structure rather than anything else. So it's a very adaptive data structure that has been used here. We shall discuss it very soon, and shall see that this adaptive data structure, it is the basic, it's making the effort more efficient one. So let us see. So here IE is termed, referred, IE is the abbreviation of incoming element. So we have tried to explain it in pictorial way. It's the best way to depict it, we thought. So the incoming element comes, the first incoming element comes without any, it has no competitor, so it straightway occupies the front one, because since it doesn't have to start with, since it doesn't have any competitor whosoever, so it belongs to front one. Okay. So this is one. This is the one case. In case two, there are several cases, and based on different cases, we shall take adjustments on our existing data structure accordingly. I mentioned that it is more a data structure related contribution rather than anything else. So here exactly the data structure that plays the fundamental role here. So case two. So the incoming element shows indifference or mutual non-dominance. Indifference and mutual non-dominance, they may be used interchangeably. So shows indifference or mutual non-dominance with all the front I elements, an arbitrary front I. So it means that typically for a front I find that my incoming element, it basically all the points in front I are maintained by front I. It maintains indifference with all of them. So suppose in my front I, many existing points are there, new incoming element arrives, it is compared with all these points, point 1, point 2 up to point R within the front I, and incidentally it is found that, well, all the points, existing points, point 1 up to point R, shows indifference or mutual non-dominance with this newly arriving incoming element. So this is the case. Okay, so what do you do then? So basically, originally there are many points, and then the last new incoming element or arriving element, this new element is further accommodated. So what is the common way? I don't know how many, I mean, after the process, how many elements are going to be there, going to stay there in front I, given a specific front I. How many elements we have to accommodate, we never know beforehand. So what is the common data structure? The common data structure that we can perceive of is a simple list, linked list. So that is precisely what we are doing. So long there is indifference, we go on adding within the front I. There is another part. When we start, do we know how many fronts will be there? Answer is big no. For example, in the previous case, where we dealt with 10 points, when we started, did we know that the number of fronts that will be generated hierarchically is 7? So 7 fronts will be there out of to accommodate 10 many elements. Did we know that? Answer is no. So there are two aspects which are variable. One is how many fronts we don't know beforehand, and within each front, how many elements we need to be accommodated, that also we don't know. So both these are not known to us. So in this type of situation, we have to work. Now, one favorable, or rather the positive point is that somehow if we are in a position to manage to accommodate all the fronts, whatever number of fronts we need to accommodate, if it is possible for us to achieve that in some way, and given a front, any number of elements can be accommodated by linked list, which we have already explained. If it is possible, then we appreciate that any number of any new arrival can be accommodated. So which means that truly this algorithm or this process or this procedure or methodology works in an online manner. It is capable of dealing with stream data. So that is where exactly we are in now. Case 3, third case. First two cases are straightforward. Third case is that the incoming element dominates all the front elements, front I elements. That means given a particular front I, all the elements front 1 up to point 1 up to point R, suppose it is found that the new element, it dominates all. That means all the R points within the front I. So what will be the scenario? Naturally, see, it's like this, the question of replacement comes here, because this incoming element is more, or is dominant one compared to all the existing R elements residing in front I. So what is the straight way out? Let front I be allocated to element EI, the right hand side scenario, and naturally, since front I is being occupied by IE, that means incoming element, so existing front I elements need to be kept as it is, but only the front index gets changed. Now it is from front I to front I plus 1. Okay, so now hopefully we must appreciate that this insertion of a new front I, that means at the front level, horizontal level, we also need a linked list type of structure, because otherwise we cannot ensure that any number of fronts can be inserted anywhere, and we never know how many fronts need to be incorporated or inserted throughout the process. So it's a linked list in respect of different fronts, and each and every front, they may contain linked list. So that is why it is a nested linked structure or nested list structure that way. Okay, so list of list sort of thing, right? With the first level of list accommodating fronts, and within front, second level or inner level of list or nested list takes care of these points within that front. This is the third case. Now, fourth and fifth case, they are more difficult. So, incoming element dominates some, not all. A few front elements, but not all. Okay? So, how is the scenario? So, this is my existing front I, point 1 to point R. Now, my incoming element arrives, and I find that, say, without loss of generality, let us assume that, or let us find that, say, point 1 and point 2, they are dominated, and rest are getting they are dominating basically. So according to this newly arrived element, the existing R many points within the front I need to be decomposed into 2. And accordingly your frontal adjustment has to be done. So this is a case where the new element is such that for its presence, or in order to accommodate it, you need decomposition of the existing. So this is the case. Case 5, incoming element is dominated by some front I element. This is the other case. The previous one was dominating, and this is the dominated by. Okay? So earlier, please note this symbol. This is dominating symbol, greater than type of symbol. In case 4. In case 5, it is dominated symbol. Here, right? This is the indifference symbol or a mutual non-dominance symbol. So here also we need decomposition, but in a reverse way. Okay, so whether it is dominated or dominating, that means case 4 and 5, you need to make some decomposition within the existing elements and adjust your fronts accordingly. For this, you may need to introduce new fronts also. Okay? So these are the exhaustive cases, and there cannot be anything other than these that we have already considered. So to sum up, NLS, nested link structure, introduce a novel approach for handling online datasets in a multi-objective framework. So it's characteristically online compliant. Provides a good best case time complexity and worst case time complexity as per order of MN square, equivalent to FNDS. Complexity wise, time complexity wise, it still stands there. Methodology is straightforward and impactful, but lacks computational efficiency. Lacks means, we cannot beat the existing one. Unfortunately, also doesn't work accurately for larger dimensions. So when it comes to the question of dimensional, higher dimensional case, it reports something difficult, some improper also. So that way it has got certain limitations. But approach-wise, it's a very simple one. So this is NLS. This is a publication which has been published in ICPR. Took place in December in Calcutta. So this is NLS. Now, question is future of MO and NDS. Now, before anything further, now these shortcomings, the question at this stage is quite justified to raise the point. Well, NLS suffers from some shortcomings. So is it possible to fix them and make some improvement? Well, answer is fortunately yes. So there is one of our work which is now under consideration in a journal called BNLS, where if it is accepted, then the order is order of mn instead of order of mn square. So time complexity wise, there is, serious improvement. And what is even more important is that this scalability issue, which NLS was suffering from, that means for a large dimension, it gives some occasional, adverse or some improper, reportings. BNLS doesn't suffer from that. So that is not yet published, so we are not in a position to discuss on that. So this is where exactly we are now in terms of already published work. So now now the floor is open for questions. I will be happy to answer a few, and that's all. Thank you for your patient hearing.
Thank you, sir. So, any question from anybody?
Okay, I think.
We'll
Any question? Nale, otherwise we may stop. So thank you once for all your patience.
Okay, so thank you, sir, for your excellent talk.
Welcome. Thank you.
And what you have shown that the present work that you have done, it's changing the exponential time requirement to the linear time requirement. That is, I think, it will be an excellent work.
Not yet published. Let us see.
Not yet published, but means when you are saying that it is done, so I think there are some merits, so that I can expect.
Let us hope for the best.
Yeah.
Thank you.
Yes. So so again, thank you for accepting my invitation and delivering this talk.
It was my pleasure. Anytime
you
you just call me, and I cannot resist myself. Okay.
Yes, that I know, sir. For you only, my PhD is possible. That I can admit anytime.
No. It was your merit. I just tried to give some clue. That's it.
Yes. Means your support was awesome. So without that, it was not possible. So thank you, sir.
Thank you very much. So may I leave now with your kind permission?
Yes.
Thank you, audience, all my audience, for your wonderful participation and patient hearing. So I am leaving now. Thank you once again.
Okay.
Bye.
Thank you, sir. Thank you.
Yeah, bye.
Okay. So after this talk, right now, within few moments, we are sharing the link for test. Okay, it will be through Google Form. We will share that link through WhatsApp and through email. Okay, so you have to complete the test within 45 minutes, and there will be 45 questions, no negative marking. Clear? And you have to join again sharp at 6:30. Sorry, 7:30. Now it is means 18:38. So you have to join at 19:30. Okay, and at 9 start the valedictory session.
Sir,
That
is
is
there
7:30.
negative marking? Yeah. Hello.
No negative marking.
Okay, sir.
No negative marking. Yes. Any question? Somebody raise his hand. Any question? Gitanjali. Any question? Yes, yes. Ask question. You
Sir,
don't have to raise your hand. You can ask question. Yes.
sir, may we leave now?
Yes,
May we
yes. You
leave now?
should leave. Yeah, you should leave and you should give exam. Time is
Yes, sir.
45 minutes.
Okay,
Okay, you
after
should
that
leave
I will
and
join.
then again. Yes, you have to join sharp at 7:30.
Okay, sir. Okay, sir. Thank you, sir.
We will start the valedictory session and two more eminent persons will be there. So your presence
Okay.
is required and attendance will be counted for valedictory session also.
Okay, sir. Thank you.
Okay.
So one more thing,
Yes.
that uh, in the questions MCQ link, there is a tab as affiliation. So what we should write there
No,
after
I think I have not yet.
designation?
I have not yet given. Is it given?
Yes,
Yes, yes.
yes, yes.
So
So I've
whatever
just
you
opened
can.
it. No, that is
Yes,
a
yes.
required field. That is a required
What?
field after name and designation.
Ma'am, I hope the name of the institution in which you are working right now, that will
Okay,
be
okay.
there in the application.
That
Yes,
will
yes.
be the
That.
affiliation.
Yes,
Okay.
yes.
Yes,
Okay.
yes.
Okay. Thank you. Thank you.
Where you are working. Where you are working.
Okay. Okay. Thank you.
Okay. So give the test. And one more thing, listen, there are one more thing. There are basically two feedback forms. One is through ATAL portal and another one that I have shared. Okay, Pitam has shared. Okay, so you have to fill up two feedback form, ATAL, that ATAL form in the website that will go to the AICT. And this one that we are sharing, this one is for institutional feedback. First give the exam, then later you can fill up the form, feedback. তুই খালি গায়ে এখানে এসির মধ্যে ঢুকে ফ্যানের হাওয়া খাচ্ছিস, তারপর ঘোরা ঘোরা করছিস। রাত্রিবেলা দেখতেই পাচ্ছিলাম কিরকম ঘোরা ঘোরা করা বন্ধ হয়ে গেছে। তুই এখানে কেন ঢুকেছিস? বেরো, এখানে লাগবি না, নিজে পড়াশোনা করবি না।
Yes, Dipangada, can you hear me? Can we start now?
Yes, yes, we can start.
Okay, thank you so much. So, good evening, everyone. Now it's the final time, as we know, that we are at the fag end of this entire 6 days program. And we are now going to just organize the valedictory session, the final formal ending part of this entire story. So as we all know, this valedictory session is the time to summarize the entire proceedings, as well as to understand what are the take home actually. So we need to talk to about these issues first. So there will be 3 different cross sections, what we have actually selected, better to see in that way. So the first cross section will be from the participants end. So we have actually selected one very individual, a special individual, I should say, that who is having the synergy from one particular professional background, and she will be actually having the ideas related to the corresponding understanding what the particular things we have actually assumed and understand in this particular FDP, as well as the synergy from her end, that is in the medical practice, how this particular things can be understood. So we are asking Professor Arunima Chaudhuri. She is MBBS Calcutta, MD Gold Medalist, PhD MBA, PDCR, DCMH from NIMHANS, Famer Fellow, GSMC, MHP, University Topper. So I request Professor Arunima Chaudhuri to say a few words related to how was your experience and what you feel about the synergy that these particular FDP and the understandings of these ML, AI, and the data science, how this can be actually practiced in your medical field. So please, Professor Chaudhuri, and say a few words.
Sir,
Thank you.
for giving me the opportunity. Respected organizers, distinguished faculty, and fellow participants, as we conclude this transformative 6-day journey through the fascinating landscape of artificial intelligence, machine learning, and data science, I stand before you with a heart full of gratitude and a mind enriched with knowledge that will undoubtedly shape our professional endeavors for years to come. Over the past 6 days, this learning experience took us from the fundamental principles of AI, ML, and data science to the cutting edge frontiers of technology. Dr. Dipankar Datta's inaugural session set the perfect tone, providing a solid foundation. We witnessed the evolution of technology through insights of evolution of language models to reasoning models, illuminate Microsoft's expertise illuminating the path from simple pattern recognition to complex reasoning capabilities. Dr. Kurit Das opened our eyes to the AI renaissance, showing us how we have moved from merely learning patterns to generating infinite possibilities. The technical depth of this program has been exceptional. Professor Tonmoy Shom's session on fuzzy rough set best future reduction provided us with sophisticated mathematical tools for data preprocessing. Dr. Kaushik Ghosh's exploration of machine learning foundations and frontiers equipped us with theoretical knowledge and practical applications. The session on AI and IoT transforming the connected world beautifully demonstrated the convergence of AI with other technologies, showing us how interconnected systems are reshaping our digital landscape. Dr. Sumit Misra, RH Software, insights into protecting digital payments, leveraging advantages in AI, highlighted the critical role of AI in securing our finance future. Perhaps one of the most thought-provoking sessions was the presentation on human-centered AI in the ages of agents and generators. This session reminded us that despite all technological advancements, the human element remains centered to AI development and deployment. It challenged us to think critically about who is serving whom in this age of intelligent agents and generative systems. The comprehensive overview of generative AI and tool landscape and the deep dive into AI agents and their applications have prepared us for the next wave of AI innovation. These sessions have shown us that we are not just users of AI, but potential creators and innovators in this space. The interdisciplinary nature of AI was beautifully showcased during the session on From Pan-Genome to Application Graph Models from Genomic Insights, demonstrating how AI transcends traditional boundaries and finds applications in the fields as diverse as healthcare and biotechnology. The session on elementary geometric features and image analysis applications provided us with practical tools for computer vision analysis, while the exploration of non-dominated sorting in multi-objective optimization framework equipped us with advanced optimization technique essential for AI systems. The key takeaway are the future belongs to professionals who can integrate AI, ML, and data science across multiple domains. Technology must serve humanity, not the other way around. This rapid evolution in the field of the AI demands lifelong learning and adaptation. Theoretical knowledge gains value only when applied to solve real world problems. Now, ethical consideration. With greater technological power comes greater ethical responsibility. I extend my heartfelt gratitude to all the distinguished experts who shared their wealth of knowledge with us. Each speaker brought unique perspectives from industry and academia, creating a rich learning experience. The diversity of expertise has provided us with a 360-degree view of the AI landscape. As we return to our respective institutions and organizations, we carry with us not just knowledge, but a responsibility to be catalysts of change. We must share what we have learned, implement these insights in our work, and contribute to the advancement of AI, ML, and data science in our communities. The tools, techniques, and trends we have explored over the 6 days are not just academic concepts. They are the building blocks of tomorrow's innovation. Let us use them wisely, ethically, and effectively to create a better future for all. This FDP has been more than just a learning experience for a medical professional. It has been a glimpse into the future of healthcare. The convergence of medical expertise with AI capabilities promises to usher in an era of precision medicine, improved diagnostic accuracy, enhanced patient safety, and more effective treatments. As we integrate these technologies into our medical practice, we must remember that our primary commitment remains unchanged: to heal, to comfort, and to care for our patients with compassion and expertise. Thank you.
Thank you so much, madam. Actually, you have done our work easier. So what the summary we require, you have read this, and thank you so much. That was a really comprehensive summary. And the way you have actually represented and presented everything about all the depictions and what the particular take home from all the speakers, all the 13 speakers you have included. So it was really a wonderful job. Thank you so much, madam.
Thank you, sir.
So with this, let me move on to the next speaker. As we have said already that we are having these cross-section from different aspects. The first one, as you can see, the second one will be from academia. So we have invited Professor Shamurjit Kaur. He is a professor, senior professor from National Institute of Technology, Durgapur. And let me say brief words about him, the background. He did his BSc from the Department of Mathematics, Presidency College under the University of Calcutta. Then he did his master's in applied mathematics from the same university. After that, he did his PhD in the Department of Applied Mathematics, Vidyasagar University. As I have already said, he is a professor there, and he joined, I think, the institute since 2007, if I am not wrong. And he had, as I have seen, that presently till date, 36 doctoral students under his supervision. And at this moment, around 250 publications he has. He has an immense experience in the research domains like multi-objective optimizations, fuzzy systems, soft computing systems, as well as he's doing a master job in the ML as well as in AI. So I request Professor Shamurjit Kaur to say a few words about the particular aspects, the scopes, as well as the futuristic vision of these AI, ML, and data science. Over to you, sir.
Thank you, Professor Ghosh, for your introductory talk. So, first of all, I come to my thanks to the organizers for giving me this opportunity. I'm really very happy to be here to be part of this 6 days event on future path of artificial intelligence, machine learning, and data science. So obviously, in today's scenario, those who are working in machine learning and data science, this topic is very relevant for today's scenario. So before going to the some mathematical aspects or some challenges related to this AI/ML, so let me first just give you one thing, because maybe you have listened so many lectures, so many talks during last 12-13 lectures during last 6 days. So obviously you have some basic ideas of artificial intelligence and machine learning, maybe some applications of related to those fields. But being a practitioner, or maybe those who are just beginner in this domain, so what should be the path? What should be the path to follow as a practitioner? So from my point of view, so at first, for the beginners at least, you should study at least one language, maybe in Python or R, which are by which you can code or start your algorithm. And obviously the next step should be the basic theoretical background, which are mostly related with some mathematical background, statistical background, maybe some optimization task. And then you should start with some classical machine learning algorithms like say logistic regression, support vector machine. Those are basic algorithms or classical algorithm. And obviously the next step should be the recent algorithms or most applicable algorithms like related to deep learning, convolutional neural network, maybe some advanced topics like transfer learning, and other related topics. And most challenging and the final step should be, what are the recent challenges, what are the major challenges of these AI/ML topics. So obviously my target is, because you have already some knowledge in this area, already you listened 12, 13 important lectures during these 6 days. So at first I should say what our ML model actually does. So maybe we can say ML is a subfield of artificial intelligence, which focusing of developing a system that can learn from the data. So obviously you need some learning as well, which are basically relevant to data. So both machine learning and data science are very much associated or related to artificial intelligence. So what is an ML model actually does? So obviously we can say there are thousands of machine learning algorithms are available nowadays. Maybe 100 machine learning new algorithm is coming every year. So what are the challenges? Which algorithms gives you the most best performance for your system or for your real system? So every machine learning algorithm has basically the three important components. First is representation. So how to represent your system or a real problem into a machine learning model. So then obviously the optimization play a very crucial role, very important role in machine learning algorithms. Then obviously the evaluation. So these are the three basic steps of machine learning algorithms. So in general, when we go for the practice of machine learning, the steps, or maybe for developing a machine learning model, we should follow the basic steps like collection of data, pre-processing, feature extraction, generating training data, then choose the loss function for minimizing the loss, then how to learn your model, and finally generalize the error. So that means generalize the error terms. So obviously these are the simple steps generally we can follow when we want to develop a machine learning model. So obviously when we deal with the others, they maybe for classical algorithm we can design a model by using the following steps. But when we want to solve the problem by using some advanced algorithm like deep learning, convolutional neural network, so then obviously the data is very much important. So always the data, more data sets is required, because but when we consider a huge amount of data, it is again there is a huge challenge for us. So let me give you a simple example why not always big data is very much helpful for us. So you may just I give one information. So in 2021, one Swedish scientist from the University of Guadalajara at one Swiss scientist, he calculate pi to a 62.8 trillions of digits. So now the question is, by using 10 decimal place of approximation of pi, we can calculate the circumference of the earth up to precision less than 1 millimeter. With 32 decimal places, we could calculate the circumference of our Milky Way galaxy with a precision of hydrogen atom. So what's the need of that huge amount of precision or huge amount of data? So now the question is big always better? So obviously this is one of the important challenges, but in the other aspects, deep learning has emerged a game changer in healthcare, offering tremendous potential in revolutionary diagnostic systems, treatment, and patient outcomes that my previous speaker, madam, has already told. So ability to analyze complex medical data with remarkable accuracy and speed, obviously unquestionable. So now the question is, what there is so many barriers? So why we are not doing all those medical systems through AI? All are AI based. Why we need the medical experts? So obviously there is a concept of dark data. So there is a massive amount of information that are generated from our system. So according to International Data Corporation, there are 90% of data which is unstructured and never be analyzed. So are they all good or bad? So how actually digital waste is polluting our planet or polluting our system? So data pollution is also a very big question here. So now the question coming about the data quality. So data cleaning is one of the important points. So how to clean the data? So obviously for the bad data sets, there are some inconsistency, extraneous text, missing data, redundant information. So many things are there. So how actually this garbage in and garbage out apply in large language model? So now most important point is in medical database, there is obviously the most important point is unavailability of data. So ideally for say medical image data set, maybe we cannot exceed the data sets maybe more than 500. Mostly we can collect the data set from 500 to 1000 patients. So obviously for small data set, there are various problems. So small data sets, when we use small data sets, that means we can develop some models by using our small data sets. There is a very important mathematical issues are overfitting and underfitting. This is the concept. So overfitting is basically the high training accuracy but low test accuracy. That means you are fitting your model in such a way that you have a high training accuracy, but when we apply it for the testing, accuracy is less. So model is obviously your model is over complex, and it fails to generalize the real world. So on the other hand, it may be your problem is simple. That means you may have the low accuracy in training as well as test. So due to its oversimplification, because for example, your problem is basically in a nonlinear nature, but you are using a linear system for solving your model. So obviously there are many concepts to deal with such overfitting and underfitting. So there is a concept of bias variance trade-off, regularization. I think already my previous speakers discussed regarding this. So another important point, maybe in medical domain, people are using some concepts of synthetic data. What is the concepts of synthetic data? So obviously it is an unavoidable and reliable solution when gaining across the real data would be very time consuming or costly, or sometimes it may be impossible. So now the question is synthetic data future of our machine learning models? So again, there is a many concepts like bias, fairness. So data bias is one of the concepts nowadays. Obviously, data bias is the silent killer of machine learning fairness. So how to deal with such data bias? So obviously data bias, not only the data bias, there may be AI ML bias, human review. So many types of bias are associated with this. Also, one of the important point in statistical point of view, that is imbalance of data. So you are considering some samples, maybe 80% data from male, 20% from female. So when we do this, when we take the samples, so obviously there is a oversampling concepts. So how to deal with, there are many statistical approaches related with this. Maybe we can overcome that. Also, there is another concepts when you are deal with some real problem by using some neural networks or support vector machines or very important mathematical models or mathematical techniques. There is an important concepts of hyperparameter tuning, because already you have the basic concepts. There is a concepts of model parameter and hyperparameter. Those parameters which are related to your algorithm, so those are basically known as hyperparameter. So there are many concepts of hyperparameter tuning. So for these types of challenging, similarly, there are many data sets that are having temporal effect. Those data sets may be time series based models and so on. So there are also different techniques by which we can maybe handle this type of challenges. These are basically some statistical or mathematical challenges. So obviously, which may affect those types of AI based or machine learning based model. But the most important challenges is data pollution, because that already I told you. So nowadays, because of there are so many garbage data, so many relevant inconsistent data, but they are unprocessed data, but they are harm or they are doing pollution in our planet. So now the point is how this type, because already I told you machine learning models and data science both are subfield of AI. So obviously they are very much important for AI. So but this AI can be dangerous today in different aspects. Maybe due to this type of reinforcing biases, uncontrollable decision making, massive workforce disruption, maybe AI powered cyber attack, so many things. So one of the important challenges nowadays, this AI is misused for distraction of wire, because nowadays there are many wires are happening. Maybe they can use autonomous weapon, AI-based, AI-powered surveillance, cyber warfare, defects, swarm-based drones, many things. So maybe some examples. China introduced world's first AI commander maybe Gaza ware. So many examples. I'm not going to the detail of that. So in summary, so we may conclude in this way. So what are the conclusion and ethical implication of this type of AI/ML challenges? So obviously the first point, no accountability for mistakes. Escalation due to faster AI decisions. Maybe sometimes our target is misidentification. Sometimes they can attack school, hospitals, etc. So we need some actions on that. Ban the lethal autonomous weapons. Ensure human in loop in the control. And maybe in future direction of AI and ML, we can enhance the cognitive ability and adaptability of our system. Transparency of AI decision making is most important future direction of research. Addressing social challenges ethically. So ethical AI is most of the important direction of research nowadays. Obviously, there is one important, because due to the huge data sets, so our computer are not work well. So utilization of quantum computing power is also another important future direction of research. And finally, the seamless human machine interaction is the most important point. With this, I can conclude. Thank you. Thank you very much.
Thank you so much, sir. I think I am audible now. So the point is, as you have already mentioned, that this will be the vision of the future works in the aspects of ML, AI, and data science, whatever. So we should be human-centric, we should be ethical in the applications, and we have to control and measure the applications while using. The flood of the use of AI ML can be very dangerous, so we have to control that one. So thank you so much summarizing the entire vision and the future aspects of these entire components of these FDP. Thank you so much once again. So we move on to the final speaker for today, Jayanto Datta Majumdar. He is from the industry, and he holds a mechanical engineering degree from Jalpaiguri Government Engineering College, and PGDBM in finance from IIM Calcutta. Presently, he is the founder and chief growth officer of Go Wealth Investment and Indus Wealth, and also non-executive partner of an EdTech solution. So over to you, sir, Mr. Majumdar. So can you hear me? Jayanto Dr. Majumdar, are you there?
Yes, I can. Am I audible?
Yes, sir. Yes, audible. Very much audible. Please, sir. It's your platform now. Please.
Yeah. Thank you, Dr. Ghosh. Hello. Am I audible, Dr. Ghosh?
Yes, audible, sir.
Yeah.
Yes, please.
Sorry. Yeah. Thank you, Dr. Ghosh. Thank you, everyone. And it is indeed an honor to be part of this such a distinguished panel. I personally thank Dr. Datta, Dr. Dipankar Datta, and Ghosh for inviting me into this wonderful session. I was fortunate to go through some of the sessions in last few days, and I must admit that I have never seen such a versatile FDP program in the past. So, of course, I have not attended majority of the sessions, but one or two sessions which I went through, and the curriculum which I have gone through, it's amazing. I can understand that this entire forum must be hugely enriched in last 6 days, this FDP program. So I want to congratulate all of you. I was told that majority of this audience is professors or teaching professionals. There are doctors and there are researchers. So I'm humbled for such a distinguished forum, and I'm particularly want to congratulate each and everyone for completing this wonderful FDP program for last 6 days. I'm just having a little bit of logistics issue, so possibly I will off my video. I'm just turning the video off. So what I'm trying to highlight is that I want to encourage all of you, particularly many of you are teachers, and teachers are nation builders. They shape the future. So it is indeed a duty. In our industry, we used to call it a train the trainers. So here, this FDP program is primarily a wonderful approach to train the trainers. Go back perspective. With this, how you can populate these students, that is most important. Now, we are at an inflection point. As a nation, we are right now the fourth largest economy of the world. This is much different the time some of the senior faculty members or researchers. So right now in India, we are a very aspiring country. So it is the duty of all the teachers to encourage, motivate, and inspire the students. Sorry, presentation, I'm trying to speak from my heart and my experience. You can call it experience AI. And unfortunately, I was told to inspire the students, but personally, I'm in a little bit of a difficult scenario. Let me just tell you that day before yesterday, I got an invitation. Perhaps some of you are aware that there is a film right now in the little bit in controversy. That's Bengal Files, which is right now not being shown in Bengal. I got an invitation for a special screening in National Library. Right now, I'm standing in front of basically toilets of National Library, where the a special screening of the movie is happening. 850 people glued on that, and I came out because I promised Dr. I will attend that. So that's why logistically I'm in a little bit of difficult scenario. But so I'm personally little bit of demoralized also, because the kind of last 120 minutes long. So personally, a little bit of demoralized seeing some of the.
Kindly switch off your video.
Oh,
switch
sorry.
off your video. Your voice is breaking.
Oh, sorry. So coming back to this, I was trying to highlight that we are at an inflection point, and it is very important that we energize our students to take up the bigger challenges. They should be aspirational. Let us encourage them to take a big bet, big dreams, so that we can reach to the next level. And I am pretty positive that with the kind of enrichment we all are going through, we can able to percolate some of these to our students and researchers, and which will help us. And India ecosystem is also getting better, and entrepreneurial initiatives, but these are a big socializer. So people from remotest part of, like say, Balurghat or Purulia, again, no offense to any of these places, but what I'm saying that sometimes people who are in Calcutta, they used to have an access to better information, but now this is not right. So we need to see how our students or our researchers can come up with new ideas, and we can encourage. Now, what with that, last 6 days, I'm sure that regarding AI, ML, and data science, deep learning, or you call it agentic AI, all of the things must be talked about and said. And obviously, I'm not an expert on that. I spent 26 and a half years in a IT service company in Cognizant. So in Cognizant, from the formative days of RDBMS, then we worked on ETL tools, then we worked on data visualizations, coming back to big data, little bit of artificial intelligence. So all these spheres we have touched. What Samarjit Kaur was saying, right? Data quality, data cleansing, even quantum computing. I don't know much. I don't know. So all these things we came across. And what is most important is that what are the use cases we have worked on? And like in the AI space, right? What is most important is the what problem of our customers we are solving. Now, AI is a huge industry. In 2024, it was $3 billion industry. Now there are four. By 2030, it will be close to a $2 trillion industry. So you can imagine, right? So analysts are saying that AI industry will grow at a breakneck speed of 35% CAGR, which is amazing. So this is a huge opportunity in front of us, and AI can solve many problems. Like even some of the use cases which like I am no longer in Cognizant, I have started my own wealth management initiative, but based on my 26.5 years of experience, and I was also fortunate to work in the various part of the world, work with some of the best minds and some of the large customers. So areas where we saw that AI we partially helped, like fraud analytics. We worked on risk management. Even so, I heard one of the Dr. Arunima. I heard in one of the customers we are talking about remote diagnostics. How we can use the Internet of Things, although Internet of Things is not exactly a part of this curriculum, Internet, but I think there was a session on this Internet of Things and AI, how we can do enable the remote diagnostics, and from there also an insurance company, how we can do the real-time claim settlement. So basically in China those days, I'm talking about 2015-16, so using AI, how a company called Ping An Insurance, which is one of the largest general insurance company, how they are doing real-time claim settlement. Then obviously there are digital assistants, there are speech recognitions. Then another thing where we have seen that social listening. So for example, there is a large bank, they have launched a new product. Now obviously they want to get the feedback. Now feedbacks are available in social medias, right? So Dr. Kaur was saying big data, right? There's a huge amount of data. Now how we can read that data, how can clean that data, how can remove the unstructured and noises and data pollution, how can figure out the data. Okay, the customers are saying this because customers' voice are very important. So these are the areas where you used to work. Now AI in the AI world, right? So the most important thing is that how we can stay relevant. The question is, if you go to the industry, some analyst will say that only 20% of our engineers or say masters are employable. So what will happen to the rest of the 80%? Then someone is saying that 25% of the job we're going to do by robot in 2027. So we are already in 2025. So 25% of the job will be done by the robots. Then another forecast is that some I don't remember the exact percent, but some 50% or 40% of the jobs which is going to exist in 2030 have not even invented. So that means 5 years down the line, 30, 40, again, the percentage can vary, or 2032, the 30% of the job which people are going to engage, the job does not exist. For example, like say 10 years back, how many of you are thought of that people are working in Zomato or Blinkit or the other, there is another quick service provider, right? So these jobs were not existed. Again, though those are low-ended job. Now in our, like say, in our college days, mobile phone was not there. Now if you see that time, today, a huge millions of people are working on the mobile workforce. So like some are building mobile phones, Samsung or OYO or Oppo or Apple's. Some are building their accessories like AirPods or covers or cases or glasses. There are companies who are providers, like in India, Jio or Airtel. They are providing the internet or the data backbone. Some people are working on the softwares, right? The billing software of the mobile company. So in a nutshell, there are millions of people working into this space, but these jobs were not existed in the late 90s. Maybe there are very few people. There are very few people could be in Bell Labs or maybe in DRDO or some hi-fi research center they were researching, right? So coming back to that old forecast, that means some good amount of percentage of jobs which are going to be there in the market for 2030 or 2032 are not invented yet. And people are saying 80% of the people are not employable. And another person is saying 20% of the jobs will be done by the drones. Recently, I went to a college, and I am a mechanical engineer. When I met one of my friend also, and they were saying in the shop floor, they are also using for heavy equipment, they're using drones. They are using small robots, right? And this is a conglomeration of multiple skills. For example, here mechanical, instrumentation, even semiconductor, all the skills coming together at the same time. Some of the AI experts, some of the coders, they are writing the code which enabling them that, and the outcome of these, the drones and robots. Now why I'm saying this? Because there is a thought that AI is going to take my job, right? Because already there are quite a bit of technological uncertainties. But I can assure you that no, AI is not taking the jobs. AI is creating the jobs. See, if anyone from our time, like I have done my class 10 in 1990. So when I were in class 11, so there was a English not story, some fiction, 2 pager, which is called Technology for Mankind. Now, the first line of this essay was, man has won his dominant position in this planet by means of technology. Now, this is very true, right? Because we are the dominant creature in this planet. And how we have became that? Because of our adoption to the technology. So technology is the wheel of progress. Like say, when the wheel was invented in Babylon 5,000 years back, right? And even a few years back or few decades back, when internet was invented, these are big bets. Personally, I feel the internet is the biggest one in the recent times. Although there are analysts which say AI is even bigger, and this is not my thought. Even a person like Sundar Pichai, he is saying that the impact of AI is on the humanity is more profound than electricity and internet. Personally, I do not think, but obviously I am no one to Sundar Pichai, right? So if he is saying that carries some weight. So AI is very pervasive. If you go back 25 years back, who are the world's top companies? Like you can see some large, maybe oil and gas companies, ExxonMobil, PetroChina, you could find them, Citibank. But as we progress, right, today, world's top companies are all AI companies. In the past, companies are saying we are a digital, Larsen and Toubro, right? Larsen and Toubro have a IT wing, but Larsen and Toubro primarily known as a supply, manufacturing, construction, not manufacturing, construction, project company. They used to say we are a digital company because we are using the digital technology at every sphere of our organization, at the same time enabling better productivity gain and benefit for our customers. Today, companies are saying we are an AI company. So everybody is busy in adopting AI. Now, in this AI space, what is the most important thing is that future-proof ourselves. So when you work with your students or research guys, they need to make sure that they are future ready. So along with today, there is a new technology, Python. 5 years later, Python may not be there, but there will be some new technology. So what people will learn? Everything can be outdated. So the most important aspect is that we have to adopt the continuous learning part. And through this AI, developing AI integration skill, learning how to work with AI, not competing against it. So how we can leverage the power of AI. Now, another very important thing is the system thinking and big picture thinking. Now, many a times we do not look for the big picture. We can only look for, okay, in the trenches, okay, this work I need to do. And I'll tell you a small story on that a little later. Maybe I will finish in 2-3 minutes, Dr. Ghosh. I don't know whether I'm running out of time. So,
No,
system
it's
thinking.
okay, please. Yeah.
Understanding, is the audio is okay? Because here signal is a little poor. So,
Have the video, it's working better. Yeah.
Okay. And this place is all many CISF guys are also there. And this is my first visit to National Library. So understanding the architecture, scalability, integration, not just coding. The other day I went to another university in Calcutta, outskirts of Calcutta, and somebody saying, I am working with the AI. I said, what exactly you are doing? Then I found that she's finding some solution or search from ChatGPT. So AI is not ChatGPT. AI is not just Python. AI is much bigger than that, right? And developing cross-disciplinary skills at a higher level, the various streams are converging. Even medical science and engineering are converging. Nowadays, there are engineering colleges, they are biomedical engineering. They're talking about building electronic medical devices, which needs medical knowledge, which needs instrumentation knowledge, which needs electronics knowledge, and definitely there needs the computer knowledge, because people like you, again, you are not students, I apologize, but in a nutshell, we all are students, right? We all keep learning, and we are in a knowledge industry. So this cross-disciplinary skill is very important. Going beyond development with business, design, data, operation. And I saw there is a particular, I think, session on human-centric roles. Now, AI won't replace. AI will not replace everything. AI will not does not know empathy. They will not very clear on ethics. Like Dr. Kaur was talking about ethical AI, right? And we also know there is a term called ethical hacking. So this empathy, ethics, leadership, product sense. Now, India, even in my Cognizant, right? When I used to work in Cognizant, we're a service company, but we don't have many products. Right? So why US is leading in the technology space? Because they are building products. Now China is also coming up very strongly, but India, we are lacking. So it is important you encourage your student the product sense, product idea, so that we can we should not draw comfort and nuance skill development, keeping that mind as it unfolds. So it is very important that along with this AI, we also develop that how we can work with AI, how we can have the continuous learning experience. Like Einstein said, that Albert Einstein once said that learning is what remains when one forgets everything what he or she learns in colleges. So that means, yes, we learn quite a few things in learning colleges, maybe in this FDP, but that's not all learning. Learning is a continuous, lifelong thing. It is both inside out as well as outside in. So it is very important in this AI world, in order to stay relevant, in order to stay future proof, we have to have this adaptability and continuous learning role. So AI is not always that like AI is destroying jobs. AI are creating new jobs. Like say, because for these drones, right? Maybe engineering, mechanical engineering jobs shift to AI. Maybe some other pharmaceutical industry jobs where AI or computer engineers was never able to penetrate. Now this is coming to computer engineers, because computer engineers are needed to develop the remote diagnostics. Like I have a neighbor in my flat. He's a radiologist, right? And now they have developed a interface, scanning interface, where they get the radiology reports across the Bengal, even from the remote part, where they don't have super specialty hospitals. They're sitting in next door. They're analyzing this. They're recommending this, and this is very foolproof. And some of these cases, accuracy of AI is much bigger than that. So that means the jobs are shifting, and along with the job shift, we need to also stay relevant. And another thing is that not every time that when we talk about the customer, right, we need to understand what problem customer is thinking. So in order to solve the AI problem, we have to understand customer business. Like there was a session on credit card or payment gateway, right? In order to build a payment gateway with AI, we have to first understand how the payment gateway works. What are the nuances? What are the regulations? So if we do not know that, no matter how much we aware of Python or Java, or we do like say, big data, it will not going to help. Like in my long back, we were working in a project with a German stock exchange. It's called Deutsche Börse, and they are trading platform used to call Zetra. So one of the German customers said, "Have you understood our problem?" And then he said, "If you understood our problem, then 50% of the solution is already there." And this is a powerful statement. Anywhere in your life, like sometimes you try to understand the customer problem, try to understand the question even. Read 2 times, 3 times. Maybe we are thinking that, okay, question is a very straightforward. No, may not be. So the problem, if we understand very well, that itself will give you the 50% of the solution. And that's a learning I got from one of the customers, because we can learn from our customers. So all I'm saying that industry, we give a lot of emphasis on learning the domain of the customers, because end of the day we are solving the customer's problem, and we have to think like a customer's way, customer's view. And the way sometimes some customers, so for example, sometimes we used to do digital maturity say assessment. Now different company, let's say if our customer is say a retail company and another is a bank, may not be a corporate bank. So the kind of like say digital maturity a retail company is needed, a corporate bank may not be needed. So corporate bank may be okay if they are 3 out of 5, whereas if you go to a technology company, let's say you are doing this for Google, Google has to be in the top 5. So customers' need can also vary. So with that, I just go back to that one point that we were talking about, that system thinking and big picture thinking. This is very critical. And I would request you to inculcate that to your students. Sometimes we think that, okay, we are working on this particular syntax or data cleansing, but why we are doing, we do not know. So I will just finish with a small story, so which is little bit resonant with this. That there are two guys, right? Two guys who are working on a scorching heat and they are basically breaking some stones. Naturally, it is not easy, right? When you are in a very scorching heat, high temperature, and doing such a mundane job of breaking stones, you will be irritated. Now, one guy came and asked the first person, "What are you doing?" Now, obviously, the first person, let's say that person name is Tom, and Tom got irritated that, "Don't you know what I'm doing? I'm just breaking some stones." And that was his natural reaction. Now, the second guy, the same question when it was asked, second guy, he stopped his work, took his towel and cleaned his sweats and very proudly said, "I'm building a temple." So that means the second guy is an entrepreneurial person. He or she is well aware of the overall objective. He knows why the stone is getting broken. Yes, the stone breaking part is a very mundane, very troublesome, tiresome, but one day this will help me to build a temple or a palace or a bridge or a dam. So he or she is aligned to the bigger goal. So I would request you inculcate this thought to your student, so that we don't want only only that we don't want our students to be a stone crusher. So it is a choice whether they want to be a stone crusher or they want to be a temple builder. So with that, I would like to finish. And if you are able to see my background, that the film producer Vivek Ognihotri and all this, they are now entering. So I'm just putting the mic off. So once again, I would congratulate all of you for this wonderful session. And personally, once again, thanks Dr. Dutta and Dr. Ghosh for giving me the opportunity. I do not know whether I'm able to do it much justice, and I personally prefer always a face-to-face, in-person talking. But thank you again. Thank you. Good luck.
Thank you so much, sir. I should say one word, that your particular talk was more cinematic than the cinema what you have viewed. That I can say only. So it's our pleasure, of course, that you have with us. And you have actually mentioned that one. This is the true spirit of the application of these AI ML, whatever you say, that the point is like, this is the futuristic vision of these AI ML, that we should control the things properly. And as you have already said, that this will not kill the job, perhaps it will generate more jobs, more opportunities there. Only the point is, it should be human-centric. We have to understand the issues. We are the creators, we are the innovators, and that particular AI devices are going to help us only, with or without emotion, with any particular tiring job, that entirely they will work 24/7 just to help us. But we will create, we will generate, and we will actually rule the world. This is actually the main essence of your story, as I have understood. So thank you so much, sir. And with this, let us actually move on to the fag end of this program. Now I request the host of this program, the entire coordinator of this particular FDP, Dr. Dipankar Dutta, to just conclude the session with proposing the vote of thanks. Over to Dr. Dutta.
Okay, so now it's time to close the program. So this program is organized, as you know, this program is organized by University Institute of Technology, Bardhaman University. Basically, this is the 25th years of this UITBU, University Institute of Technology, Bardhaman University. So we thought that we should organize one FDP in 25th year of this institution. So few months back, I and Dr. Ghosh discussed among ourselves and decided to apply to AICT through our higher authority, that is Professor Sunil Karpama, and to our Vice Chancellor. So And then that FDP got accepted by AICT, and then we organized this FDP. Then means at the time of application, we have to approach different speaker that okay, whether you are agreeing to give the speech. So as you have seen that, okay, see, 13 speakers have given their consent and they have delivered their speech. And so I want to thank them, and I want to thank Dr. Ghosh for supporting me. Without his help, this program is not possible. Then I want to thank Pritam De, who has worked a lot from behind. And last of all, I should thank the participant. Means they have means listen. Sometimes the means the session become boring. Still they have listened, and at this age, I know that most of the time we are teaching, so we don't have the habit of listening. So listening 20 hours is not a joke. Means last 6 days we have means this session continue more than 20 hours. So it's not a joke. And after that, you have given a test. A test result, we have to see what are the result. Then we have to send the marks to AICT, and we have to send the feedback to AICT. We have to send the attendance to AICT. Then AICT will see all this thing. Then there are many other formalities also. We have to submit a lot of documents to them. Then AICT will verify all this thing. Then AICT will issue certificate. Okay, so at this moment we don't have any means we are not in a position to say that when AICT will give certificate. It is up to them. So okay, another thing is that we have opened a WhatsApp group, and you know our phone number, you know the WhatsApp group also, and you know the mail ID. So we will keep this group open for at least 1 month, so you can communicate, no problem. Okay, and don't ask question that when we will get certificate, because it is not in our hand. So that will be decided by AICT when they will give certificates, first thing. And another thing is that, see, what is the purpose of doing this FDP? The purpose of doing this FDP was that to pass this information, means what is AI and what we can do using AI, machine learning, and all this thing. Okay, so I know some of you are expert, some of you are not expert, but still you got something from this FDP, and that should be the starting point. And we have made a group that okay, in that group, in the WhatsApp group, we have more than 100 people, so from different background, diversified background. So what we can do, we can exchange our ideas. Okay, we can collaborate if required. We can exchange our thought, we can exchange our knowledge. So means this is just the starting point. So we can consider this as just the starting point. Okay, in future we can collaborate and we can work together. Okay, with this expectation, I am concluding this session, and I am concluding this workshop or FDP. Thank you, everybody.
Thank you, sir.
Thank you, sir.
Okay, so
thank you, Dr. Dutta, for your final version. And this is actually the end and the conclusion of these entire FDP. Thanks to everyone. And please stay with us, as Dr. Dutta already mentioned, about any particular updates or anything else. If you want to cooperate or collaborate in certain ways, of course, you are welcome. So stay with this WhatsApp group. Thank you, everyone, and good night.
Good night, sir. Thank you so much.
Good night, sir. Good night, sir. Thank you, sir. Thank you.
Good night.